Guys of my Security Gone Agile. I'm Matt Tesaro. I will be doing this presentation. There's a bunch of stuff here. I have very information-dense slides, mostly so that if you want to look at this later, you'll have this stuff. I mostly just use it to remember what I wanted to talk about. And as I'm going along, if you have a question, just raise your hand, shout it out, throw coins a pound or greater. I don't want to get hit by something that's in the P range. That's no good. So let's get started. So who am I? I'm Matt Tesaro. I've been at Rackspace since 2011, October. I'm in the Rackspace Product Security Group, which is a group that lives in our product group, go figure, which is where we develop the various OpenStack and other products that end up being sold to customers, right? And at Rackspace with the Product Security Group, we're kind of I don't know, we're unique from my other positions where I actually report up through the QE or quality engineering chain. So where I actually live, our product security group lives underneath the VP of quality engineering. So we kind of work hand in hand with the QE folks. That's my work side of me. The OWASP side of me, I was a board member, I think from 2009 till 2011, I think, or something like that. And I've been doing the OWASP Live CD since 2008, which is now WTE because I don't really do ISOs anymore. And I started an OpenStack security project as well. So DevOps, CIs, APIs, oh my. So just so that we have sort of a common idea of what DevOps is, right? It's the idea that we're going to combine sort of, or break the older mold of developers do code, they chuck it over a wall, and then ops has to somehow deploy this thing. And you have this adversarial relationship between the two, right? Let's all get along, let's all drink the Kool-Aid and be happy. So it's a collaboration, agile experience, and the idea is really to sort of have each group sort of feel the pain of the other group, right? So that if the dev guys are producing code that's undeployable, they feel some of that pain. And if the operations guys are making deployments really painful for the dev guys, they share that pain. So hopefully, in the end, we all get better, hopefully. And there's tons of automation and release coordination. That's a big part in my mind of DevOps. Okay, just so we have all the terms laid out. CI, continuous integration, CD, continuous deployment, but I've also seen CD be continuous delivery. Those are both kind of the same thing, depending on how pedantic you want to be. TDD, test-driven development, and APIs and application program interface, right? Just so that everybody has the same terms. Quick and easy stuff. So the problem. So the cycle time for software is getting really, really fast. Rackspace has a range of products in terms of speed and maturity. The most aggressive of which is deploying last year on average 72 times per week, which is nutty. Just flat bonkers. And depending on the product group, some of them already have continuous delivery, some of them don't, where it's a spectrum, right? Based on the product team and how sort of mature they are. And then for a security person who used to work in a much more traditional waterfall shop in a past life, the normal, like, this is my testing week doesn't exist when you're deploying 72 times a week. It's like, okay, let me, my window's over. Right? So it's just not really functional. So my first reaction was to say, no, I need a week. We have to slow down. And that just won't happen, right? Businesses don't want to slow down. If nothing else, there's this huge first-to-market, first-mover advantage, right? You may not have the best thing, but if you get it up first, you kind of grab market share and it's off to the races. So trying to talk to the business about slowing down is just, it's not going to work, right? That's not tenable as a security person, so that's just not a viable option. Oh, I've already said this. Traditional software, little time to test, right? And then you add in DevOps, continuous delivery, and you're even having more in CI/CD, and your Windows and Windows are getting shrunk, right? All of this is sort of working against you. And then even better, at Rackspace, we have a lot of Ruby and Python. Those are languages that I can't automatically use a traditional static analyzer to look at, right? Because static analyzers have no idea what to do with Ruby and Python. So once again, a place where I could maybe inject some automation, I can't. So it gets even worse. And then RESTful APIs, that's the other one. We have lots and lots and lots of RESTful APIs. We don't produce waddles for those APIs. This is an OpenStackism. They don't like waddles for whatever reason. So I don't even have a way to automatically talk to APIs. If I want to test a RESTful API, I have to read the docs, right, and test it. There's not like in the SOAP world where you could pull a WSDL and maybe at least automatically make the default method calls, I can't do that now. So there's all these things sort of working against you, and you kind of feel like going down to the pub and just drinking and forgetting about it, right? And if you're trying to do manual testing, which it just takes time, that's even harder. So what do? Like automate everything. Automate the software testing, automate infrastructure, and automate automated security testing. I thought I worded that differently, but oh well, it's early. So I'm gonna talk through those three key areas. First from a design and principle point of view, and then I'm gonna talk about what we've done to try to implement those things at Rackspace. So first things first, I would challenge people who haven't been a developer. My first job out of college was at a international telecom whose operations were almost all in Europe, but the data center was in Texas, which was very strange to me. But when I messed up, it was kind of nice because we had a lot of Belgian customers. And so I would get woken up at 3 in the morning with a really angry Belgian yelling at me in my bed. And it's look, okay, let me wake up at least. I know you're just getting up now, but I'm actually really, really asleep, and let me go to the office and we'll get it fixed. But so I would challenge people who are in the security, application security field to think more like a developer. Like, think about breaking your, right? Because if you're developing an app these days, you don't do like the big waterfall thing where I have all my requirements and I go, you break it into pieces. So start thinking about how you can break the testing you do into little and preferably automatable pieces. The other thing we do at Rackspace tons is threat modeling. And threat modeling is really nice because I'm time constrained, right? And now I have an overview of the system, and if nothing else, I can see the parts that look a little wonky or interesting. And maybe if I'm time constrained, I only look at the wonky or interesting parts, right? It's just very pragmatic, but it has served us very well. And then think about the difference of like time of tests, right? Long and short running tests. Those short running tests, you can almost automate those in cron job those and have them just running weekly against infrastructure, right? And then when you do actually do a formal review of a particular, in our case, product, you can look at the results of those cron jobs and have a good binding them to get an end result, right? And that way you can mix and match depending on the context. So like SSL is a great example. SSL cipher checking, you need it for websites, you need it for APIs, you need it for a bunch of stuff. Make that its own little test, but I won't do, say, cross-site scripting tests for an API, but I will do SSL for both, right? So make those, combine them all kind of Lego blocks, stick them together, and get what you need to get your job done, hopefully.
Sorry, another question.
Yeah.
Coming back to the story, you said that acceptance criteria in that story. In terms of your testing, would you expect to have a full block of testing completed 100% to accept that story as complete, or would you have a rate, 80%, yeah, I'm happy with that?
Okay, so the question was, do you do an entire, does the entire story have to be tested for you to be happy with it, or do you do 80%? I'll be honest with you, a lot of times we do 80%, because it's a time trade-off, right? If I can only get 80% done before it rolls to production, then it rolls and I look at the 20% after it's in prod, because it's just how it is, yeah. You really have to be pragmatic, particularly with our more aggressive groups. And so that's another place where having these things combinable is really important, because in the context of this particular product, these 3 tests are really need to make sure they're not messed up. You run those early, right? And then maybe those other ones that are interesting but not critical, if those run after they go to prod, that's okay.
Yeah, run exactly the same kind of.
Okay. You feel my pain. Yeah, it's painful. It was a rude awakening for me. Okay. So I and a coworker talked about this idea of test-driven, instead of test-driven development, test-driven security, right? Where you have DevOps and CI and CD, your testing has to be nimble, oh my God, I'm gonna say the A word, agile, right? So in TDD, the overall concept is you know your code works when the tests pass. For test-driven security, for me, you have a baseline of security when your app passed the tests. And baseline is a key concept, because there's a lot of security purists who will say, oh, well, that test only tests 50% of the possible SQL injections. It's complete and utter trash. I'm like, well, I tested the most common half, and I'll test the other half right after it goes to prod, and I'd rather have half of it tested than none of it tested, right? So I have gotten very pragmatic in my security thinking, quite honestly, because if I didn't, I just wouldn't get anywhere. Oh, yes, it's a time to mourn, right? So in my mind, at least at Rackspace, traditional application security is dead and buried. Like I did used to work at a traditional waterfall shop, and I was hand in hand with, we had an IV&V was what we called our QA shop. And we had a 2-week window where we did testing, and I tested at the same time the QA people did, and it was, you know, yay, wonderful roses. Well, that's dead, for me particularly. It's gone, right? And I would say if you're in this place, I went through the 5 stages of grief, right? I had denial, right? I like this Agile, oh, that, I never said this really, but I know a lot of security people like, this Agile thing is a fad, it's just goofy. You know, I used to joke that at one place that I worked, we had sticky notes all over the walls. I said, like, one really aggressive cleaning lady and her development process is derailed, right? And I had another coworker who was really quite mean who would move them and then walk on. I thought, ooh. Anyway, so that's the stage of denial. You know, get over it. I'm sorry, Agile's here. I don't think it's going away. So anger, right? There's no way I can test it in that time frame. Like, and if I see another freaking sticky note, I'm gonna go nuts, right? Get over it. Like, it's time to not be angry. Bargaining, well, I can test 2 of it in 2 days, but I'm not really sure. And you kind of are trying to convince management to give me a little more time, please, right? And then depression, like after that launch, I'm gonna go update LinkedIn. And then from aliens, right? Game over, dude, game over, right? Thank you, aliens. And then acceptance, right? Now you start actually talking with the developers, and you say, you know what? I need you to work in a story to get this regression on this login thing. It's not terrible, but let's get it in the next sprint, right? Or like, hey, I looked at your deployment recipe and I found some things that you were missing. You really should say, you know, put root no login for SSH. Here's a pull request. Just add that into your Puppet or Chef. We're done, right? And that's kind of where you need to get. So I'm going to fly through these, or hopefully we can fly through these 5 stages of grief by talking about 3 different things. This is sort of how I broke it up for product security at Rackspace, looking at it from an infrastructure perspective, an apps and API perspective, and then the code. So let's talk about infrastructure. So I don't know where you are in your infrastructure automation maturity model, but at Rackspace we have Chef, Puppet, Salt, and Ansible, depending on the team, which makes life interesting, because I sort of have to be an expert. No, I'm not an expert, but I know a lot of them, right? But at first you're like, oh, God, I gotta know all this junk. But then I thought about it, and if I can bless how they deploy a node for an API and understand that that's hardened, that means that every node that we deploy is hardened. So this is actually a huge win. And it felt kind of weird at first, but it actually is fantastic. And I'm going to go really quick over this, but for those who don't know the Chef's Puppet, all the infrastructure automation stuff, they have this idea of a sysadmin who has some sort of either hosted server or private repo that has recipes or salt stacks or what have you that know how to go down and deploy nodes, right? And there are cookbooks or stacks or playbooks or whatever that go through and talk about, so I want you to set up an Ubuntu system, and if you do, I want you to do install autoconf, flex, and bison, right? Whatever, right? So they're just recipes that say do these things on a machine.
Did you get the developers to do your recipes for you?
I'm sorry?
Did you get the devs to do the recipes? Or did you get the developers to do it?
Honestly, at Rackspace, it depends on the team. Some of them, there's a really blurry line between devs and ops, and others, it's much more distinct. So it depends. Yeah. Generally, it has been the ops people. The nice thing here is, right, you can grab a lot of these things and get decent baselines and kind of modify them to fit your work, so at least you can get some stuff out the door quickly. But to me, this is the place where I spend a lot of security cycles. Because like I said, if I can get this recipe that not only launches an API node, but an API node that is hardened and meets our requirements for a hardened node, I'm kind of done. Because I know every time they press go on this, right, it's going to go out consistently, right? And then if you want to have good karma points, try to get those hardening things merged upstream, because a lot of the recipes you pull will make, you know, I don't know, Nginx run on a server, but probably not how you want it to run as a security person, right? And then grouping and tagging. So almost all of these have some sort of ideas of putting a tag or a label or some kind of categorization on the servers you're launching, right? So here's a DB server, and DB servers get MySQL, and there's a web server, and web servers get Apache, and there's a cache, and caches get Mcache, right? So you tie these recipes into tags or some such thing. And maybe for all of them, you have a monitoring thing, and every box gets monitoring, right? So there's this mix and match sort of category idea. Oh, now the interesting thing you can do is sort of map security tags to requirements, right? If you have a requirement to have your logs pushed off to a centralized logging server, well, that's like a recipe you write. And then you just mandate that that's part of your standard push, right? Good way to get some quick traction. And then the other thing that we've done somewhat at Rackspace, not entirely as much as I'd like, it's not done yet, although nothing's ever really done, is for each group and tag, we had this idea of, if you think about deploying infrastructure, you have the idea of an architect, right? Or conceptually, this is the model we talked about. An architect, the person who designs the building, right? This is what the building looks like. And then you have the sort of construction company, the builder, right? And they go out and they build the building, right? So that's the guy who pushes go on the recipe. And we have this idea of an inspector, right? The guy who comes in and with the checkboard and ticks all the boxes. Did you have, is the pipe, this far, is it grounded, yada, yada. So we wrote an inspector that we can hook into the post-deploy system and do a review to make sure that that thing deployed matches what we expected. So we have a little inspector, in essence, with a clipboard walking around ticking the boxes. And I'll talk about how we did this at Rackspace particularly a little bit further down the line. And then this is where we're checking for code compliance, not perfection, right? This is another place where you're like, where are the bare minimums? Because it gets very tricky to test certain aspects of deployment, but there are some that are just really easy, right? Is like directory indexing not turned on in Apache. That's really easy to check, right? So check that, right? And you can, for me, I'm worried about security, quite honestly, but you can also have multiple facets to this inspector, right? What about scalability, right? What about compliance? If this is a PCI environment, well, then I got to do maybe some more things than I do in a normal environment, or less, or who knows, right? Okay. Agent, yes. One mole to rule them all. So at Rackspace, I would joke that I would come home from work and clean out my pockets and I'd find a server, right? Because we have like infrastructure and cloud and virtual all over the place, right? There's just like popping a server at Rackspace is a non-event. And so in this environment, we would actually have two dev or pre-prod production environments would come up, would be used for a deploy, and then would just get destroyed, right? They just come up, you test them, and they go. So in that environment, you can't, unfortunately, a lot of the security tools have this idea of a mothership that you install, and it sits there forever and talks. Well, that doesn't work when your environments come up and down like the wind, right? Because otherwise, you're continually installing the mothership in the new environment, which is just a pain. So we're starting to use agents that are dropped on systems that can report back to a mothership that doesn't ever leave. But then those environments can come up and down. As long as that agent is part of a standard build, I'll get a mole, right? A secret agent in on the box that can then give me visibility in what's going on. And if they destroy that system because they're done with their testing or their pre-prod or what have you, it doesn't matter because their next one they build will also have that agent. Reports to the mothership, I'm gonna settle that. Oh, one other key facet, if you wanna make your sysadmins or ops people happy, is make sure that agent is read-only, right? And make sure that you can convince the sysops that it's read-only, because they don't like the fact that you're playing with their boxin. You look like you have a question, ask it.
All right, okay. The safety, I think it's going to be on your pre-prod environment.
Right.
It's going to be part of your chef script for deployment.
Yep.
So that means you won't be able to use your set. Would you put that agent into your production environment as well? Or would you'd have to modify your chef script in order to take the agent out?
Okay, so the question, just so we have it recorded, was these agents, do you put them just in pre-prod or do you also roll them into production? And right now at Rackspace, I'm going to do the lawyer answer, it depends. For some groups, we are rolling it all the way to production. Other groups, we haven't gotten there yet. We want to get to the point, though, that this is sort of just part of the standard. Because like when we had the Jenkins vulnerability that came out that was really ugly, I had wished I had had this, right? Because if I had an agent on all the boxes, I could just write a little rule that says, tell me if there's Jenkins running. They could all narc out the boxes that had Jenkins. You gather those IPs, find out who owns them, and go knock on heads, right? Yeah, it really makes life much better. Well, I'll talk about that later. There's a point I'll make later. But yeah, no, great question. And then ideally, right, add a quick and dirty dashboard to show these things, right? Like for the Jenkins thing, if we'd had it, we could have turned everybody that had Jenkins red And then as Jenkins got updated, turn them green. And I could get a quick visual representation of like, wow, we got lots of red, we got work to do. Or there's one or two, let's go find those guys and figure out what's going on, right? Oh, you can roll your own. There's Mozilla MIG, which is actually more forensically based, but you could easily, I'm looking at tweaking that maybe to not do forensics. That's a Mozilla security project, open source written in Go. Interesting agent. Their idea is to use the agent to find signs of compromise. So you can give it a hash of a problematic binary and then say, does it exist on the system? And so it's a sort of a way to forensically look out, but I want to change it to NARC, quite honestly. Cloud Passage is another vendor that if you want to buy it, they have a nice agent-based system to do these kind of things. Yeah, this is the next slide. You guessed my next slide. So if you do this really right, you're almost turning vulnerability scanning on its head, right? Because it used to be you deploy your stuff, I run Nessus, I give you a report, this is what's wrong, right? One of the things we've done is, and I did this actually in a previous job as well, is I just subscribe to all of the things that we used, and that at the previous job, that list was at least fairly finite. Right? For all of the things that I used, I subscribed to the announce or the security or the, right, for that list. I got a Gmail account, and then I wrote some interesting filters, so if keywords showed up in them, it forwarded it to me. Right? So I made my own sort of baling wire and duct tape system to give me alerts when there were vulnerabilities in products I cared about. Right? And this is very useful because you can sort of turn the scanning on the head. Now you're not going, hey, by the way, I just did a scan and your thing's out of date. You can say, today, I don't know, Tomcat issued a patch, and go check your Tomcat because I see from my agent that it's out, right? And I'm not having to do a scan to find that. I'm being told that, which is huge. The other thing is we kind of cheat, quite honestly, in our threat models because we do data flow diagrams, a traditional Microsoft thing. But then I got the ops and the architects and the devs in the room. I pummel them with questions. What framework are you using? What language? What server? Just get all that metadata you can because you have the guys for an hour or so. Like, why not pull it out? I already talked about rolling your own. Right? I did this at a previous job, and it worked actually shockingly well, where I just signed up to a whole bunch of vulnerability lists. And then did some filtering. Secunia Vim has 40K plus products, and they have a thing where you can say, I use this, and send me an email, and yada, yada, if you want to pay for a commercial thing. And I just love the fact that it reverses that scanning thing. Right? You're proactively helping the teams. Like, you don't have to have the fire drill, because I finally got a chance to scan your infrastructure, and oh, God, this really critical thing is there. It's proactive. We can have a nice, calm conversation over, I'm in England, so over tea, right? And talk about it, right? It's much better than the mad panic. Okay, let's talk about apps and APIs after I take a drink. Okay. So PDFs are great, but bugs are better, right? So I don't write reports anymore, which as a former pen tester is frickin' beautiful. And anybody who's pen testing here knows, like, getting rid of doing reporting is the Valhalla of pen testing. Instead, I just do bugs now, and they go straight into the bug tracking systems over dev teams. And I'm in a backlog or an issue tracker, depending on how the team wants to do things, right? So I don't do the big reports. Occasionally I do for political reasons, but those are the exception, not the rule. This is nice because then it's just the normal workflow for a developer, right? It's just another bug. You can go talk to the Scrum Master and say, let me get, what sprint can we work this into? It's not a, here's this 500 pages of PDF, ugh. Like, go make sense of it and come back to me, right? Ideally, you want to have a security category in whatever bug tracking something you have so that you can differentiate between functional and security bugs, and also you can run numbers about what your program is doing. And the bonus points if your tracker has an API, because ours does, and we've automated this. So I just push bug, and it whoop into a backlog, which is beautiful. I said it's part of the normal workflow. One thing to watch out for is, for the more reticent teams, they might say, oh yes, we've got that in our backlog. And by the way, we haven't looked at our backlog in 8 months. Right, so you do have to sort of keep them honest. A lot of times I've had good luck sort of talking Scrum Masters into doing occasional security sprint. Hey, you kind of got a lot of security bugs in here. Why don't we take a 2-week window and just knock all these out, and I'll stop bugging you, and life will be good for you, right? And a lot of this is learning how the team treats issues, because we have lots of diverse teams, and for us at Rackspace, it's all over the place. So you kind of have to know how to speak their language. Regrettably, at this exact same time, Dan Cornell is talking about thread fix, which is a nice way to get metrics out of your security bug tracking, as well as pumping them into issue trackers. So thread fix has this idea of pulling in vulnerabilities from multiple sources, sort of normalizing them, and then wiring them into bug trackers. And so what we did at first is we would just put them directly into the bug trackers, but then Scrum Masters and stuff would move them around, and we'd have to go, oh, it wasn't the backlog, now it's in an issue, now it's in a sprint, like, where is it? So we made our own. This becomes a security sort of source of truth that integrates with the bug tracking system. And the nice thing with ThreadFix is it'll let you know that it got closed in the bug tracking system. So I can look in ThreadFix and say, that thing I reported last week just got closed. Let me go talk to them and make sure it's cool, and we can retest. Whoops. I found the screen. Ah, yes, nag, nag, nag. So the other thing we did is for each, we came up with a 5-tier risk or severity classification system, right? Standard thing. No big deal there. But the one thing we did is we put an SLA to each severity. And then for the SLA, it's not getting it fixed. It's getting a remediation plan in place, right? Which gives some flexibility, right? Maybe this is a really horrible issue, but because it's a design fault, you can't do it in 7 days. I mean, just physically impossible, right? So, okay, let's get a plan within 24 hours to know that the team's gonna start working on this, and we're gonna do this mitigation, et cetera, et cetera. So our SLAs aren't based on being fixed, but having a remediation plan in place. Once we have that in place, now I have something I can sort of put a line in the sand and wait till we get there and then go talk to the team, right? We're a week out, how are we doing? That kind of a thing. Yeah, remediation is fixed, age. And then what we've also done for less aggressive teams is in our source of truth, we start aging these, right? We don't have a fix yet, and we should. So let's do a, hey, you're a week out. We just send a little gentle reminder to the project manager. And then maybe a day or two out, we send it to the project manager and the director. And we just start walking up the org chart. And it's highly effective the higher you go, right? I'd like to work with carrots and not sticks, but sometimes you have to have sticks. Once again, if you can do some kind of dashboard for your metrics, this is great, right? Because then the manager can go, why does this one product have the big thing in the chart and everyone else has little things? And for the nag tool particularly, when you start walking up the org tree, I would want some executive cover fire because some directors get really grumpy if you start sort of showing them out. Right? So make sure the directors are happy with you nagging people.
You still get the issue with Owen's books that you think, actually, this is really trivial, you know, we'll get it at some point, we'll get it at some point, and people say, look, this is only never going to happen because the way you've tested this is why we found it.
Yeah, that's unfortunately part of life. The question was, do you have the thing where people say, yeah, this is not that big to fix, but we're not going to, we're not getting to it, we're not getting to it. That's kind of the death by backlog thing I alluded to. And yeah, that's part of the, sometimes that's, you know, solved at layer 8 where you go just have some nice conversations with people and twist some arms. And sometimes you can just go down to the devs and go, look, man, I'm bugging you, you're sick of me. Like 3 lines, you check it in, we do a pull request, we're done. Right, let's just, and I've like stealthed into sprints fixes because it's like, I'm gonna keep talking to you. So you could like get rid of me for a long time if you just do 3 lines of code. Right, done. Okay, so reports equals findings plus automation. So what we've done is actually standardized on ASCII doc, but pick what you want. Pick a markup language, right? Because if you're a tester, you probably are fine using VI or Vim or a text editor, Sublime, or whatever, right? You can just quickly knock these things out in text. A simple markup. And then you can use something like pandoc or ASCII doc as a built-in to convert those to HTML if you need a web report, or PDF if you need a handoff of PDF, or whatever you want. So when I write a finding, we actually write the findings, well, initially, we've improved on that, but initially we wrote the findings in a markup, and then multiple people on the team could all write findings, and the report was glue all the findings together and ship it off to the person. If they wanted it as a HTML, great. If they wanted it as PDF, great. If you wanted it as a doc, great. We can gen all those.
I take it that's tagged against the story. Is that tagged against the story or the acceptance criteria of the story?
Depends. Yeah, the question was, is it tagged to a story? And it depends, quite honestly, because somebody asked me what languages do you have at Rackspace? And I said, can I tell you what we don't have because it's shorter? So yeah, the teams are very diverse. Oh, but the nice thing is, right, your testers are writing the least as possible, right? I have boilerplate, and you can take, if you have the stuff in easy to parse format, you can take out and sum up numbers for them, like why is somebody counting the number of highs? Like that's something a computer program can do, right? The other thing we did is started reusing these templates, right? Because your first cross-site scripting finding, where you say reflective cross-site scripting is blah, 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 is like the 400th one, that reflective cross-site scripting is blah, 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 doesn't change. Like, why am I writing that more than once ever in my life? So we've templated that, and every time we have a new finding, we can actually make that a template, and then the next time it comes around, I don't have to type it again. Oh, and this is, yeah, we started with Dratis, which was good, except for it didn't enforce correct syntax, so you try to glue these things together and the parser would break. We've now written a web app where they just enter them in as individual form feeds, and then they're atomic. And I can mix and match however I need.
But you find if you template these responses that you'll find out you've actually got 1,000 templates or...
Yeah, it is a problem. I mean, you sort of have this growth of, the question was, do you find that you have a whole bazillion templates? Yes. One thing we did with ours is that one of our tester guys will go find something and say, you can create a finding that doesn't become automatically a template. But if you think it's useful, again, you can make it a template. Those go into sort of this pending or purgatory of templates, and then myself or a couple other senior people will go in and look at them, make sure the spelling's correct and the wording's good, and then we'll bless those. So we sort of have a lot of times the purgatory gets full, but what you actually see for day-to-day use is small. I had the same thing at a different company when I was pen testing. We had like, which of the 4,000 templates do you want? And like 17 of them are cross-site scripting. Okay, cool, settle that stuff. Oh yes, leverage existing consistencies, yes. So what does this mean? This is best done by example. So I mentioned earlier that OpenStack has an allergy to waddles, right? We do no waddles. So if I'm testing, and guess what? Rackspace has lots and lots of OpenStack and lots of RESTful APIs, which is a problem because every time I have to test them, I have to read the docs and at least get code or something that knows how to talk to it before I can even start testing. Well, at least when you're dynamically testing. So one of my coworkers, and props to him, realized that the docs that we produce at docs.rackspace.com are computer generated, which means they are consistent, which means they're rather parsable. So he wrote a little bit of code that goes to the docs, pulls that down, parses it, and makes stub code in Python for all of the method calls. So in essence, we made the docs into quasi-waddles. And now I can say, I'm testing Swift, point it at the Swift docs, run the tool. The code doesn't work, but it writes 40, 50% of it for me, and I just have to fill in some bits, and I have working code. Really sped us up like crazy. Oh, I talked about this already. We automated finding and bug submission. Initially, at the first gen of this, it was literally just I had a bit of code that I could take a finding and push it into a tracker, and then we actually started using ThreadFix, right? And now that's even more automated. Automatic PDF for generation, because we're using ASCII doc, and it has a thing, I just ASCII doc-f PDF, wham. I talked about this. Oh, the other one was, that was an interesting one too. But there's another great one that one of our web apps had a bunch of reflective cross-site scripting, right? What do? Well, 15 minutes, oh my, I'm gonna go fast. What do? You go fast. He actually just made a static web page with clickable links that exercise the cross-site scripting and hand it off to the dev team. Like, until these things don't have alerts, don't come back to me. And we write a lot of scripting automation too. Like I found an issue with an API and I wrote a little bit of Ruby, handed it off to the dev teams and said, run this so that at least when they come back, I have a fairly good assurance that it's fixed. Whew. Securing code. Oh, yes. Yes, one big thing for my team particularly, findings have to be detailed enough that if I read your findings 6 months from now, I can understand what happened, right? Because if nothing else, the developer is going to come back to me and say, I don't even know what this means. And if I can understand your finding, we're all kind of doomed. And I don't have to retest it. A lot of times we can actually get QE to do this retesting for us, depending on the nature of the vulnerability. If it's easy to produce in the tools that they use. And this can allow developers to fix the issues. Oh, yeah, and I've already talked about these. Actually, there's a reflective cross-site scripting one. And script abuse via an API was the thing I mentioned, the Ruby script, right, where I just automated that little bit of, it was a particular post that the API didn't like. I just wrote a little bit of Ruby to send the post, right? And then Gauntlet is an interesting tool to do sort of test-driven security, repeatable, small testing, which I quite like. And then once these findings started flowing, I was actually getting requests, can we do developer training? Like, well, yes, we can. I want to make my job harder. Well, I don't, but I do. Oh, and then cherry pick what you look at. I talked about threat models earlier, right? Focus on those weak and suspicious areas. You know, connections to external systems, any kind of transformation, if I'm going from JSON to XML or weird parsing, right? Those are usually areas that get tripped up, right? Then you can, in your automation, do commit hooks for those areas of the code. And in OpenStack, they have this idea of +2 to accept a commit. We'll make it a +3 for those particular bodies of code, right? Because now I want 3 eyes looking on it. And by the way, if I have a commit hook, I can also be alerted and decide if I need to look at that, right? Which is a huge thing. Oh, and yeah, like, I mean, just using, we have an internal GitHub, enterprise GitHub account. Just the search inside of that has been fantastically useful. And then we've just started to, and this is a key thing, develop a list of problematic things, right? And it just is designed to grow organically as we find these things, right? I will never have the list, but I have an ever-growing list.
Don't you have any conflicts of interest on the +2 or +3 inspections part of continuous integration? Because you're then bringing in a more manual step to say, actually, I've got to review that code before I can commit it to my release branch.
Yeah, so is there fighting about the +3 versus +2? Yes, but luckily for our developers that do OpenStack, they're sort of used to that, so that wasn't much of a hard sell. Because that just, in OpenStack proper, if you commit, you must get a +2. So, you know, internally making it a +3 wasn't a hard sell. I got lucky in that regard. No false positives, right? So one false positive is worth probably 100, if not 1,000 valid bugs. Like, never, 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 this is my beat on my team, give a false positive to a team because cred points are really hard to get as a security person. You're already kind of hated, quite honestly. So if you give them a reason to hate you, guess what, they will, right? And quite honestly, if you're not verifying false positives, what better are you than a monkey that clicks next 5 times on Nessus, right? This is just your value add is the fact that I can only give you actionable items as a security professional, right? Oh, and the differential analysis, and I sort of talked about this on the code thing. Threat model plus scary parts plus code diffs, right? Let me focus on the areas that are really, really scary. And there's some stuff that I'm just never going to look at. You change the CSS of a website, I don't care, right? You change the login, I do care.
Is this where you'd actually do spikes in sprints for the scary parts? So it may be a matter of no idea about the spike there.
Can you say that again? I didn't catch it.
So your scary parts, you'd actually start looking at spiking activity rather than just going straight in and doing the work, or,
Yeah, a lot of times what we've done is just do commit hooks. And so I can quickly sort of scan and see if this is even worth my time, right? I can take a 2-minute break and go, ooh, I need to actually cut some time up for this, or no. Because more of it's just like I need to be alerted about what I need to know about and be able to filter quickly. And quiet is better than wrong, right? Hire and befriend developers. That's one of our guys have to have some sort of development experience if you want to work in our team. 10 minutes will be okay. Speak their language. A big thing for me is suggest requirements, not implementations. For example, this is at a former position, but the guy who was in charge of compliance would tell the teams, you must install Tripwire for PCI. And I'm like, no, they must install host intrusion detection. Like if it's something else, it doesn't matter, it still meets it. So don't think about a specific implementation, think about a requirement. If nothing else, developers like being creative, and you've given them the opportunity to be creative. If you say, it just has to do this, you figure out how, and I'll evaluate if it's good enough, right? And then we're all fine. Yeah, mitigation suggestions should be generic or in the language it's written in. Like don't give a Java example to your Python guys unless you want to be snickered at. And then the other thing is like fast deploys also mean fast fixes. Some of the groups, when I'm testing them, I will find bugs, and I'm on IRC with them, and I'm like, hey, dude, I just did this, and this happened. And they're like, oh, man, that's bad. And they're like, okay, it's fixed. I didn't even write up a finding yet. Like, well, yeah. So it is kind of good. Yes, sir?
Did you ever think about putting one security guy into each of the Agile teams instead of
That,
separately, or are you just
no.
not enough people?
The question was, do we have one per team? We want to get there, but we don't have enough people. That's really what it boils down to, yeah. That would be the ideal case, but we just don't have the bodies. Because then I would really, really know the product. Right, and now I have to sort of be schizophrenic and really know Nova while I'm testing it, and then I have to forget that and really know something else. Yes. Yeah, be prepared to really quickly test and re-verify, because if you have these guys that before you can write up the finding, fix it, because I literally have written up findings, put them in the bug tracker, and close them. Because they're just that fast. Okay. In my last few minutes, I'll quickly do what Rackspace is doing. Right, I've already said that we have Chef, Puppet, and Chef, depending on the team. We review the deploy scripts, we validate them with the external vulnerability scanners, and they sort of get blessed, and we watch for commits. We watch for commits, and then if we have to have them make an adjustment, we'll rescan, right? We use Cloud Passage in a lot of our deployments, and we also have a custom mole that we write for certain situations, right? It kind of depends. Cloud Passage does a lot of nice stuff. It's not bad. And it saved me from having to write a lot of code, to be bluntly honest, time-wise. And we've done tons and tons of threat models. And actually, one of my guys, we have 70 some odd threat models of all the interconnected systems, and he actually made this giant map in HTML of all the system names. You can click on them, it takes you to the threat model, and then inside of there, the external threat models are also hyperlinked. So you can actually walk through all of the infrastructure, which has really been super helpful. Product security workflow, we have somebody finds a finding, they document it in our test tracker app, that pushes it into ThreadFix. ThreadFix pushes it into the bug trackers, right? And then we have all of the metrics driven off of ThreadFix. So we've sort of automated that whole workflow. Yes?
When you say team members find an issue, how do you find those issues? So what sorts of tests do you use? Like, is it all like your own scripts?
It would, yeah, like Rackspace, it varies widely. I mean, it can go from just running Nessus and verifying false positives to doing a manual test to you're doing a SAML integration, so you write your own little SAML client and just play with it. So it's kind of the range. Most of it's manual now because we've automated a lot of the automatable things. But it could be that like we use Veracode for static analysis, and we've integrated with their API, and I pull down issues, and they go into the same workflow. So the issue may not even be technically found by us. It may be found by somebody else. Oh, yeah, we've had to re-implement the nag script because we had a minor change to the workflow, and I already mentioned this. We're using ASCII doc as our markup language and then converting that to what we need. Yes, I just said this. We use Veracode, which is nice for us because it's self-service and binary, right? Just upload your binary and go. Unfortunately, they don't do dynamic languages, so there's a lot of stuff that gets missed for us. We have a Jenkins, we have an open source Jenkins plugin that uploads into Veracode, and then we gave that over to Veracode, and they're keeping track of it now. And we did API automation to pull in those findings, and they just become part of our workflow. I've already talked about this. We do detailed finding blocks, and for more interesting issues, or if we've had to script it anyway, we take out that script and hand it to the dev teams. 5 minutes, good. I'm good, I'm good.
Do you upload all code to Veracode, or just like those parts you actually hooked in, or like you're tracking?
If we can scan it, we hook it into Veracode. Now, some teams, I have to pester them every quarter to do it. Some teams have Jenkins, right? So there's a range. Yeah. Oh, we hold trainings. We have e-learning modules. We do work with devs daily. A lot of times we are going to the stand-ups, particularly when we're actively testing our new product launch. Those are times that are kind of super critical. And we do have dev days, which is really nice. So Friday afternoon, we all get up from our desks, go hide in a conference room, and we're knocking out automation tools for our team. Because if you don't carve out that time, you will never, ever do it. And so that was a huge win for us. Key takeaways, like automate everything. And if you're not doing a lot of this now, just find paper cuts and like get rid of the annoying things first, right? Figure out a workflow and standardize on it. That's been huge for us because now we have this sort of standard workflow. I just keep adding in tools. Like we have AppScan, and I figured out how to parse the god-awful AppScan XML and shove it into our workflow, right? So now I can take those findings from AppScan and boop, off it goes. Create systems which can grow organically, right? You will never, ever finish. Ever, 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 ever. But if you make it so that you can keep adding things easily, this thing can grow over time and become even more functional. So maybe the first time I have it, it does 5%. And then a month from now, it does 20%. And then 3 months from now, it does 60%. Well, that's better than never starting or trying to get to 100% before I use it. And I've already talked about reusing finding blocks so you don't have to keep rewriting the same boilerplate junk. And learn to talk dev. That's important, right? Dev or DevOps. Whoever desires constant success must change to his conduct with the times, right? I couldn't believe I could fit a Machiavelli quote into a AppSec talk, but I got it. Yes. I think that's it. Thank you very much. And I made it on time. Look at that. Whew. It was close. I thought I had more slides than I did. Any other questions? Yeah.
So how long did it take you to get to that stage, and did you like make a lot of mistakes along the way?
Well, yes and yes. So how long did it take to get to that stage, and do we make a lot of mistakes? I've been at Rack since October of 11. I moved over into product security in March of 12, so that long. Right, yeah, it takes a long time, and we originally, like I said, tried to drop things directly into bug trackers, but then people would move them. And so our sort of pointers into the bug trackers would be broke. And I have to go find them again. So that's why we made our own source of truth. So, oh yeah, you'll learn all kinds of things and bust your knuckles. Absolutely. Other question? Yes?
Maybe a bit of this, but how much redundancy there is in the system? For example, you were saying after you deploy your public recipe, then you do this inspection stage.
Mm-hmm.
But then you're kind of gonna dig off with the pub, was the public receipt correct or not? But like, then you do risk like your redundancy. You verify that the previous stage was done correctly, but then you might need another stage to verify that.
Yeah, no, that's true.
I was just curious,
No, that's an interesting gap, and we've struggled with that in all honesty. So if I know that their Puppet is good, I can be fairly, confident that the second one will be good, but a lot of times what we'll do is on a quarterly or maybe biannual basis, just do a rescan of everything of that product from a Nessus so that you can find drifts. The other thing that we really like is hooking the code repositories of where the chef lives. So if they make a change, I can go, oh, this is now drifted. I need to go look at it again. Because a lot of it is just getting alerts and then getting, making like, okay, now I know there's an issue. Do I need to care about it? And you can quickly sort of decide. Any other questions? Going once, going twice? Yes?
There's always more questions. In terms of doing regression, do you do regression testing against all this things like your integration? And then what's the impact against the security on that regression testing?
Yeah, I'm not a QA person or a QE person. I was using regression testing, well, let me put it this way. I don't want to speak for our QA, QE group. They're quite mature. And they do regression testing. And that gets really interesting when you do things like launch servers, because like how deep you go. But for me, and in a security perspective, I consider a regression test a long-running test. So to me, it's more of like a very thorough, almost a manual test would be a regression test. Like a manual pen test would be a regression test. Because you can't just fire it off and forget it. Excellent. Well, thank you very much.
Not okay. There are plenty of seats over there. So good morning or good afternoon, everyone. My name is Mati Siman, and in the next 40 minutes or so, I'll be talking a little bit about JavaScript security and some new HTML5 cool stuff. Well, I think it's cool stuff. I'm the founder and CTO of Checkmarks, which is a static application security testing source code analysis. So I will be talking about three main things with HTML5 and JavaScript. Some new tricks, well, there were security vulnerabilities, old security vulnerabilities with older HTML. I will show you how we can harness the power of HTML5 to make these risks more dangerous. I will also show you some new tricks, and at the end, the fact that HTML5 allows you to do actually put a lot of your business logic at the client side makes your application much more vulnerable. And I will demonstrate all of that. There are plenty of moving parts in the presentation, and I need live internet connection, so I have many excuses if things break, but I hope everything will work fine. So let's start. Cross-site scripting, yeah, you all know, you all heard of, nothing new. I will show you that the fact that HTML5, you can see it over there, the fact that HTML5 is so powerful actually makes XSS much more dangerous than it used to be. So let's start with a very short example. It's a bookstore application. I hope you can see that. It has a reflected cross-site scripting, alert high. That's pretty straightforward, okay? Now, the next step, we found that the login page in here is vulnerable to cross-site scripting. Now, there is another page in the application which I want to steal the information from that page, but the other page is not vulnerable to cross-site scripting. So basically, I would like to infect the other non-XSS page to be an XSS vulnerable. So what we will do is the following. I will actually load the very same page. I will load myself inside an iframe. So the user will think he's using the main application, but actually he will be surfing inside an iframe. So the XSS external site will be able to get access to the information in the internal page. Let's see how it goes. Okay, so I'm loading the login.aspx file, and I push inside an iframe, which loads the very same login page. Okay, so I have a page inside itself. Okay, you can see here I left on purpose this gray border. So the outer page is the XSS page, and the inner page is actually what the user sees and interacts with. Okay, so let's say that I log into the site, admin. I think that I'm in the real site, or I'm actually in the real site. But as you can see, the outer page is still running, and it's able to actually interact with the inner page and still own the information in that page. So for example, if I'm going to the admin page, the outer page can steal all the information, passwords, credentials, and so on and so forth. So I was able to a certain extent, infect the inner page. That's nothing new. Okay, it existed 10 years ago. Let's see what I can do with that technique with HTML5. So HTML5 introduced the concept of canvas. Okay, a canvas is the ability to graphically interact with the page. And one of the cool features, there's an open source page called HTML2Canvas, which basically takes a screenshot of your page. Okay, converts the page into a JPEG or PNG. So basically what happens now, let me log out. Let me log in. So once again, there is now an outer page which you cannot see. Okay, I removed the gray border, but I do put an icon of a camera at the top left-hand side so you can see that something happens. So the outer page, which is vulnerable to cross-site scripting, loaded an inner page which the user interacts with, but the outer page actually takes screenshots of the inner page and sends that to the hacker, okay? So let's see what happens right now if I do a right click and view, open in a new tab. I actually see a PNG, which is the screenshot of the inner page. So the fact that there was a cross-site scripting in one page allows me now to constantly see whatever the real user sees. Okay, it's just a base 64 data, which I can transmit over the web fairly easily. Now, the really nice stuff is that this HTML to canvas, as I said, it's an open source code, so I can modify it as I see fit. One of the changes that I've made is that while rendering the page, if I detect that one of the DOM elements is a password field, I convert it to a text field, I take the screenshot, and I convert it back to be a password. So the user can't see that anything happened on screen, but the screen capture takes it while the field is a text field. This means that, well, you can. Okay, so there is a screen capture, as you can see here. Everything is masked, but if I do open in a new tab, I see the password completely revealed. So the user thinks that everything works fine, but as he's working through the application, the hacker can see anything he sees, and on top of that, to see some other stuff as well. So this couldn't be achieved prior to HTML5. So yes, cross-site scripting existed forever, okay? That's our bread and butter. But the canvas concepts allow us to achieve exactly that. And yeah?
Why do I need a canvas to do that? So if you have cross-site scripting, you can simply extract the password from the password field, so you don't need to make a screenshot of the password to see the password.
Oh yeah, I agree. I think that taking screenshots of the application to see live what the user sees has some more benefit than just statically taking information from the screen. I mean, I feel it's more dangerous, you know, the fact that someone actually sees your screen while you're surfing the application. Yeah, it's good for the reports. That's, I completely agree. Okay. Another interesting concept is the WebSockets concept with HTML5. Let's say that I'm a hacker, I'm sitting outside of your network, you have a NAT, network address translation. I see nothing but a single IP, but I do want to map your network structure, okay? Once again, using a cross-site scripting, I can inject you a script, and then you become an agent of mine. You map the network structure for me, and you send me back the network structure. So I don't have to actually be inside your network. You become an agent of mine. You could have done it prior to HTML5, but it was much trickier and less reliable. HTML5 introduced the concept of WebSockets, where the client itself, through JavaScript, can try and connect to servers. So actually, I instructed to try and connect to various servers in the organization. It maps the structure, and I get back the results. A good example would be the JSRec, an application, okay, where you tell it, everything's JavaScript, you tell it, well, I want to map the network starting from that address to that address. I want to find all the servers that have port 80. You launch submit. It just maps the network and send you back the result. I won't run it now because it's somewhat illegal to map network, so I'll leave it aside. But basically, you can choose whether you want to use WebSockets or cross-origin requests, and it just sends you back the structure of your network. Okay, so this can be easily achieved through cross-site scripting as well. Something that Krzysztof from Google mentioned yesterday in his presentation was that the fact that Chrome is actually becoming an OS actually makes cross-site scripting some kind of a command injection. And this, he mentioned this statement yesterday, and it's something that I feel comfortable with. Okay, you're actually able to inject commands into the operating system, and that's cross-site scripting. So something that he mentioned yesterday, and I thought it's worth re-mentioning. A little bit about same origin policy. So same origin policy, it's a pretty old concept. It means that a website can interact only with Windows or iframes running from the very same origin, where origin is server name and protocol. Okay, so HTTP or HTTPS or FTP, whatever. And then same website, same server. But in recent years, it is not enough. For example, if you look at Microsoft Office 365, they have a market of plugins where you can just install new plugins from the market. These plugins actually run from the very same origin as your mail server. So if someone uploaded a malicious plugin to that market, it actually, you do not benefit from the same origin policy protection. Same for Salesforce.com, okay? They have the market, the plugins run from that market, so the same origin policy does not provide any protection against these third-party markets. Okay, so with HTML5, they've introduced the sandbox concept, okay? When I load an iframe and I add the sandbox keyword, it means that although the iframe is hosted on the very same origin, you should treat it as if it's running from a different origin, okay? And then it has several parameters. Okay, so the first if you leave the parameters empty, it means you leave all the restrictions and the iframe can do barely nothing. If you add the allow same origin, it means that the sandboxed iframe will be treated as if it's running from the same origin, except for a few capabilities which you have to add explicitly. Okay, so one of the explicits that you need to add is to allow top navigation. So if we have an iframe and we want this iframe to actually navigate it out of its parent, then you have to explicitly add this capability. Okay, the idea is to prevent phishing, that you go to a site and the iframe actually navigates you out of that site. So you have to explicitly add the same origin. To allow top navigation. Allow forms allow the iframe to submit its parent forms, and allow scripts allows the iframe to run scripts. Okay, so I can add a sandbox iframe, so it will be treated as if it's running from the same origin, but for example, it will not be allowed to run any scripts. Okay, so that's the concept of a sandbox. However, there is a fundamental flaw in that concept. And let me show you a quick example. So there are 5 or 6 stages until I show you the exact vulnerability. So if I have a page, a host page, which has an embedded iframe inside it. The embedded frame is hosted through a regular old-fashioned iframe, and it tries to launch an alert message. Okay, so I have an iframe which tries to show an alert, and it's hosted within an iframe. Will we see the alert, or will the browser prevent us from seeing that alert? Okay, once again, I have a page which has another page embedded inside an iframe. Okay, not a sandbox iframe, just an iframe, and the iframe page tries to show an alert. Will that work? Yeah, because the iframe does not provide any protection. So let's click in here. Okay, and then we see the alert high. Okay, because if old-fashioned iframe does not provide any protection to the hosting page. Now, if we do exactly the same, however, instead of hosting the embedded page inside an iframe, we host it inside a sandbox where all the restrictions apply. What will happen next? Will we see the alert or not? No, okay, we won't see that. I'm sorry, it's the older page, sorry. Okay, we see nothing. And actually, Chrome provides us with blocked script execution because documents frame is sandbox and allow scripts is not set. Okay, so it works as we thought. Perfect. Now, once again, I have an iframe. I have a sandbox page where the sandbox allows scripting and allows same origin, and it tries to show an alert. Will we see the alert or not? Just nod your heads. That's good enough. Yeah, we will see the alert because we allow scripts to run. And we see the alert. So far, so good. Now, let's do the following. We have the very same iframe sandbox that allows scripts and allows same origin, but it tries to navigate it outside of its top parent, to navigate to a different site. Will that work or not? It won't work, you're right. Why so? Exactly, because we haven't explicitly allowed top navigation. So let's click in here. And well, we're within the very same site. And the message we get here is there is an attempt to navigate outside, and the allow top navigation flag is not set. That's perfect. And now we get to the really nice part. Let me just change a bit to zoom in. The fact that I'm allowed to run scripts and to interact with my parent actually allows me to parse my parent DOM element, my parent's DOM, to find myself as an iframe, to change my own sandbox policy, to add the allow top navigation property, and then to navigate out to a different site. Okay? So the fact that I am able to change my own policies, and then I refresh the page so the DOM rebuilds itself. So now we click in here. You see it tries to refresh, and here we're outside of that page. Okay, so it means that, well, the allow top navigation really is not very powerful if you allow scripts and allow same origin. Any questions so far? Okay.
Maybe you get mistake because also in origin, if iframe is hosted from another domain, from another region, it shouldn't work.
Oh, it's, okay, so it works only if it's from the very same origin. I just wanted to show that the sandbox capability has at least one problem with it. If it's not from the same origin, it will be all protected.
Hosting malicious content on the same origin as your own site is not a good idea.
Well, it's probably a very bad idea. I agree. That's, but many, as I mentioned, Microsoft 365 actually allows developers to write their own plugins, their own JavaScript plugins, and it's being hosted on the very same server because they provide it as third parties. So that's why HTML5 actually introduced the sandbox concept to allow you to host maybe malicious content on your site. But yeah, I agree, that could be improved. Yeah?
Do you consider it as a design flaw or implementation flaw by the browser?
It's a design flaw. That's how it is designed. Okay? There are at least 3 different ways to get to the very same result, to actually navigate out. So it's actually the design. Okay. I want us to play a small game. Let me just refresh the screen. So that's a very nice Pac-Man game where it is written in JavaScript. Okay, so nothing goes to the server except for the actual results and statistics. So no, let me just pause it for a sec. Okay, so first of all, as you can see here, the highest score right now is 5, 4, 3, 2, 1. And they chose to store the high score once again, in a new concept introduced by HTML5, the local storage. So now I can change it to 666. And then if we refresh the page, I've changed my high score. Okay, so the fact that, no, I'm using Pac-Man because it's very easy and funny to show during presentations, but just think about any other enterprise application that you're using. Developers tend to use these new capabilities, these new features, and to actually store information on the client side because it's actually a full-fledged database. So the first thing that we saw right now is that high score. The next thing I want to show you is, okay, I need to put a breakpoint, level min.js 131. Just a second. Okay, and let's hit play. Sorry. As I said, moving parts, so things. Okay, so I'm hitting these points, and then, well, it is called the world's largest Pac-Man because I can go to other screens. So when I try to go to a different screen, it actually it uploads the statistics of my current play. So, and actually, let's do it in 2 phases. If I do document.cookie, I see this very large piece of code which will get uploaded to the server. And then let's try to look for a URL decoder. And let's decode that. And actually, we see here the statistics. Okay, I was on page -14, -25. I ate 30 dots. I got 300 points, and I died 0 times, and so on and so forth. And now we can obviously change these values in the cookies and hit submit and upload the results to the server. And if you think about it, it's very, very difficult to have written this game differently in such a way that you won't be able to modify the statistics. I mean, since at least some part of the business logic of this game is on the client side, there is no real way to avoid it. The only way would be just to tell the server I ate a point, and then the server needs to accumulate the numbers and send me back the current value. And it will actually have severe impact on the performance. So it's not that easy to think how you could have redeveloped this Pac-Man game and to solve that issue. So many of the HTML5 applications which allow you to store business logic on the client side suffer from this kind of vulnerabilities. And another nice thing would be the following. Okay, let me just release the breakpoint and hit play. So now I want to modify a little bit, the business logic of the, just a sec. Let me remove the, okay. So now I want to do something else. I want to actually modify the inner business logic of this page. The issue is that once Chrome got the JavaScript, it's very difficult to modify it. So I have to actually catch the JavaScript on transit, modify it, and then send it to the browser. So what we will do is we will proxy the communication. We will start intercepting the communication through burp, and then refresh the screen. Let's hope the network won't fail. Okay, so we got it. Now I just need to, just a sec. I need to copy paste a piece of code. Oh, I'm sorry. Let me. Okay, so I just wanted to copy this piece of code from my presentation, and I will push it. Just a sec. Let me. Another 20 seconds until I find the correct place in the code. Okay, I put it in here, and then let's hit submit. So now let's see so it seems exactly the same, except for the fact that right now all the ghosts are, so when I hit the ghosts, they're automatically eaten. So instead of me being dead, the actual ghosts are dead so I don't have to do anything, and I keep killing these ghosts. So that's pretty fun. If you see the statistics of this page, usually there are these pills which allows you to start eating the ghosts, and this screen doesn't have any such pills. So really, there's no real way to eat ghosts in this page. However, as you can see, 33 ghosts were eaten on this page because I guess some other people actually found a way to play that game. So once again, the fact that all the business logic is hosted on your client, I mean, it's nothing new. We all know the risks, but when we analyze the source code of many HTML5 JavaScript application, we found that a lot of business logic is actually hosted on the client instead of just hosting the UI part. And when we start redesigning the code, it becomes not very obvious what part belongs to the UI and what parts actually belong to the business logic itself. So as you can see here, now each time we get a ghost, the points double, so we actually going to hit max int fairly shortly. Okay, let's wait. So it's fun. And actually, the presentation was a bit, did it a bit faster than expected. So I have this PowerPoint thing in here, just a sec. Okay, and last but not least, I will show you something based on our experience in the lab. It didn't work. Just something freaks out. Let me disconnect for a sec. I will close the PowerPoint. I think the PowerPoint causes this problem. That's weird. Just a second. Let me close all the windows. Can you see? No? It's D.
We can try another beat. Not sure which.
Let me just connect. Here it seems fine, so it seems my laptop is all right. Here's all.
Okay, so let's
Okay.
take this one.
Yeah, it's all right. So. Let me zoom out a bit. Okay, just a sec. Okay, so can you see my mouse over here? So actually the answer is no, you cannot see it. That's not really my mouse. My mouse is 300 pixel above, hidden, and I just show an icon of a mouse 300 pixel below. So whenever I move the mouse really moves somewhere around here, and I just show an icon here. Now, let's say that there is some kind of a game, and I tell the user you have to click on the numbers as they appear on screen as fast as possible. Okay, we measure the time it takes you. And based on our experiments, in about 25 to 30% of the times, what I will show you right now happens well. So the user tries to click on the 1 in here, but really the pointer is above. And then he clicks over the 2. And whenever he tries to click over the 3, his mouse actually appears on the allow to track my location. Okay, so he really clicks it. And then he clicks on number 4. Oh, for some reason it doesn't appear, but you should now see another message. Do you want me to load your video camera? Let me see how it works. Anyway, if we take a look at the in here, oh, something not connected to the internet. I had an internet issue. Let me retry that. Oh, I'm sorry. That's the proxy. I closed so many windows when there was this problem with the projector. So let me retry. Let's start as if you didn't see anything. Okay, let me close this one in here. Okay, so the user clicks on 1, 2, 3. You see now camera 4, 5. Okay, so for some reason it doesn't work. Anyway,
You should not show it to an essay,
and actually see here at the bottom, your current position is more or less 45 meters away from that location. So just by playing and, we found that many people just don't notice the message above. They just click, 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 and they do it as fast as they can. And if you just show it for just a second before they click it. And so once again, it's just a trick. But with HTML5, the ability to track GPS location, the ability to monitor cameras, to listen to your microphone, all these just makes all the security, or all the issues that we already know of, much more dangerous than that. And that's basically it. It was pretty quick. So thank you very much. If you have any questions, please feel free to ask.
Yes,
Yeah.
I have a question about local storage. You say it's very easy to access. Are there any policies, or does anyone have any thoughts about how you might be able to make it less easy, some kind of coding security or tools that might be used?
Okay, so it's a great question. The question was if someone has any best practices how to manage local storage to make it safer and useful. Someone has any recommendation how they handle it?
It's already, secure is at least as cookie. So yes, you can specify as a path to the
So yeah, the idea is to encrypt it, and it's probably as secure or as not secure as cookies. That's true. Any additional questions? Well, thank you very much. Feel free to come over our booth if you have any additional questions. I should be there.
Okay. So welcome to my presentation. My name is Sebastian Lekis, and I'm a PhD student at SAP Research and the University of Bochum. And today I would like to talk about DOM-based cross-site scripting. And more specifically, I would like to talk about a tool that we created to find DOM-based cross-site scripting vulnerabilities at scale. But before we go into detail, let's first have a look on the agenda for today. So in the beginning, I will give a short technical introduction into cross-site scripting so that we are all on the same page when talking about cross-site scripting. And in the main part of the presentation, I will then talk about our tool. And our tool basically consists of two different components. One component that is capable of detecting suspicious user flows from user input to security-sensitive JavaScript functions such as eval or document write. And by detecting such flows, we can find suspicious pieces of code that could likely contain a cross-site scripting. And then we have a validation component, and the validation component actually creates a cross-site scripting exploit and executes it against the application to see whether a suspicious piece of code is really vulnerable or not. And we use these components to conduct a measurement study on the Alexa top 5,000 websites, and we will report on the results of this study. So let's start at the beginning. What is cross-site scripting? So actually, cross-site scripting is a code injection problem. And here you can see a very simple example of a reflected cross-site scripting. And it's a PHP application, and it just prints out a greeting to the user. And it says, hello, user, and the username is coming from the URL from a get parameter. In this case, so in the legitimate case, the user would put in his username, and the PHP script would print out the greeting, send it to the browser. The browser would print out the hello username, in this case, my name. But an evil user could do this. So he could enter, instead of entering a username, he could simply enter some HTML code or JavaScript code. And as there are no checks in the PHP code, the code will simply be printed out, send it to the browser. The browser sees, well, there's a script tag, so I need to execute the code in this script, and therefore we'll see an alert window here because I used alert 1 in this code. And if you are looking into literature, we see that there are 3 different kinds of cross-site scripting. That's reflected cross-site scripting, persistent cross-site scripting, and DOM-based cross-site scripting. And I think this is not enough. So we, in our department at SAP, we distinguish between 8 different kinds of cross-site scripting. So first, cross-site scripting that is caused by server-side code. So we just saw a reflected cross-site scripting that was caused by PHP code running on the server. And here we can distinguish between 2 different kinds, reflected cross-site scripting that we just saw in the previous slide, and persistent cross-site scripting, where the payload is stored somewhere in a database and then delivered to some other users of the application. And these 2 kinds are the traditional kinds of cross-site scripting that we knew until 2005. And in 2005, Amit Klein published a paper describing DOM-based cross-site scripting. And DOM-based cross-site scripting is actually cross-site scripting caused by client-side code. So the vulnerability is not in a PHP code or Java code running on the server, but the vulnerability is on the client-side code in the JavaScript that is contained in the HTML code of the application. And in 2005, he only said, well, there's DOM-based cross-site scripting. But we think we should distinguish here, and we also have reflected and persistent cross-site scripting on the client side. So reflected cross-site scripting can be, for example, be exploited via document writes or evals or inner HTML. But nowadays, we also have HTML5 features that allow us to store data within the browser. So for example, in the previous talk in this room, we heard about local storage. And local storage is one way to store data. So we also have client-side persistent cross-site scripting here. And those 2 kinds are called DOM-based cross-site scripting. And then we have a bunch of cross-site scriptings that are caused by the infrastructure. And there are 3 different kinds here. They are caused by client-side infrastructure, by server-side infrastructure, or by the network. And for example, an example for the client-side infrastructure cross-site scripting bug was discovered last week in the Yahoo toolbar. And the Yahoo toolbar allowed you to exploit any site that was running in the browser that had the Yahoo toolbar attached to it. On the server side, we had other cross-site scripting problems. For example, in earlier times, there was the Apache web server, and the Apache web server just delivered some 404 message if a page was not available. And it printed out the page index HTML is not available. And then you were able to request the page script alert 1, and it said, well, the page script alert 1 is not available, and you had a cross-site scripting. And this was caused by the infrastructure, not by the application running on it. And for the network, we have other attacks, such as an active network attacker that intercepts your traffic and injects code into your application. For example, I think 2 years ago, there was a hotel chain in the US, and they sold Wi-Fi to their customers. And what they did is they injected advertisements into the page to earn more money with their Wi-Fi. So whenever you were in the hotel and surfing, you saw additional advertisements in your page. So this would be an example for network-based cross-site scripting. And then there's the 8th kind of cross-site scripting, and this is self-XSS. So a user copies, for example, a JavaScript URL, pastes it into his URL bar, and presses enter, or where he opens the browser console where he can execute JavaScript, and copies and pastes some stuff in there and presses enter. And if we look at these 8 kinds of cross-site scripting, we can see that the first 4 kinds are application specific. So the vulnerabilities are caused by code that is executed within the application. And the other 4 are application independent. So from an application point of view, you cannot do anything against infrastructure cross-site scriptings. And in this talk, we would like to look at the 4 cross-site scriptings that are application specific. So I would like to search for cross-site scripting within applications. And I shortly summarized, again, the simple examples for each of these kinds. And we have here a matrix where we have the client on the bottom, the server on the top, and then we have reflected and persistent cross-site scripting examples. And we already saw the server-side reflected cross-site scripting. So we have a PHP script, and the PHP script prints out the username of the user or some other user data. The persistent server-side cross-site scripting is a little bit different. So here we have some SQL statement, for example, and the SQL statement incorporates some user data here, the message parameter, and it goes to the database, is being stored in the database, and then some other stuff happens, and perhaps other users are coming and visiting the website. Then we have, again, an SQL statement selecting the cross-site scripting code from the database again and displaying the cross-site scripting code. The client-side cross-site scriptings are very similar to the server-side ones. So here we see a JavaScript that causes cross-site scripting. So here in the first line we see a variable name, and name reads something from the URL, here from the location.hash. This is everything behind the hash sign in the URL. And then it simply uses document write to write the same greeting as the PHP script would do it. But here we clearly see in the first example we have PHP, here we have client-side code JavaScript. And then we have, again, the same for persistent cross-site scripting. And here we are using the local storage. So we read something from the URL into a parameter or into a variable, and then we store it in the local storage via the local storage API. Then other stuff happens. The user comes back after he closed the browser or surfed to some other sites. Then the data is read again from local storage, and then it's written back to the page. And so the user data is being printed to the page. Okay, so now let's have a look at the attacker models. So how does an attacker conduct cross-site scripting attacks? And at first, what an attacker needs to have is an application that has a cross-site scripting. So we have here some anonymous mail provider. I guess Gmail does not have cross-site scriptings at the moment, hopefully. But there are a lot of cross-site scripting also in Gmail. And we assume we have such a mail provider and it has a cross-site scripting. So what can the attacker do? So what the attacker mostly does, he creates an unsuspicious site. And here we have some nice cat pictures. And what he does is he embeds this cross-site scripting, the site with the cross-site scripting vulnerability in an iframe. And then he hides this iframe. So when the user goes to kittenpic.org, he only sees the nice kitten pictures, but not the iframe that is hidden in it. And as soon as he goes to the kittenpics.org site, the frame executes, generates an HTTP request. The browser attaches cookie to the HTTP request, and the cross-site scripting payload executes in the context of the webmail application. And what the attacker can do, we will see soon. So here's the case for the persistent cross-site scripting. And so the general example that you may know is a guestbook application. So if you have an application, and the application stores something in the application. And you as the user have the possibility to give the content and to store it. And then you press send, and the guestbook entry is sent to the server stores it, and then some other users are visiting the guestbook. And then the server does the select from the database, and the code is returned to some other users, and you see this little alert box again. So these are the basics. And what you can do with cross-site scripting. So here I have a browser and an example application. And let's assume here is cross-site scripting. And in the legitimate case, you have legitimate HTML, and you have some form of cookies for authentication. And what you also have is some legitimate JavaScript. And the JavaScript is able to access the HTML, so it's able to change the website, it's able to extract all the values from the HTML, and it's also able to access cookies, right, a document cookie property. And now we have an attacker, and the attacker is able to use an XSS vulnerability to inject JavaScript into the application. And well, this evil JavaScript here is able to do exactly the same thing as the legitimate JavaScript. It can access the HTML, so it can change information on the page. It can extract all the information from the page. It can override JavaScript variables. It can override JavaScript functions. And it can access cookies or read and write cookies. And now I prepared two examples of famous cross-site scriptings and what can be the consequences of such a cross-site scripting. And the first example is very old. So this is the web page Bundesregierung.de, which is the page of the German government. And in 2006, I think, they had a cross-site scripting on their site. Well, some funny guy thought, well, I put a funny message on there, and basically what it says is that the Chancellor Merkel is stepping back from all of their duties because of some obscure reasons. Yes, and this looks funny at first, but this can have severe consequences. So, and there are two similar cases where such severe consequences happened. And one, for example, is when the Twitter Associate Press account was hacked, and there was a fake message that a bomb exploded in the White House and Obama was dead, and then the Dow Jones went down 10%. And I guess such messages are not really funny anymore if the stock market crashes or if there are such consequences. And another example for cross-site scripting was the Ubuntu hack, which you may know. Last year, the Ubuntu forums got hacked. And here's an article about the Ubuntu forum. And there are two important messages here. So the attacker used a method known as cross-site scripting, or XSS. And the consequences were 1.82 million user email addresses and passwords were stolen from this database. And the attack went as follows. So they somehow got a moderator account. They don't know how they got this. And then they posted a piece of JavaScript code because moderators were allowed to do so. And then they sent a link to the administrators and said, well, dear administrators, please revisit my post. Administrator went to the page. Cookies of the administrator were stolen and sent back to the attacker. And then the attacker used the cookies to access a database UI. This is an HTML database UI. And there the attacker was able to simply enter SQL statements and then extract the user data. So to summarize this, the malicious capabilities that you have as an attacker is you are able to alter web content. You can show fake content to the user. So for example, fake passwords field. You can extract all the data that is on the site. And you can use it for phishing or for asking the user for a password or similar things. And the second thing you can do is session hijacking. So basically, you can simply steal the cookies and use it for your own purposes, or you can simply conduct actions in the name of the user while your payload is executing. And to summarize this again, the two basic things that you can do with the cross-site scripting is you can impersonate the user towards the server, so you can send requests in the name of the user towards the server, and you can impersonating the server towards the user by showing, for example, fake password dialogues. And I think these are very bad consequences, and it depends very much on the application. So if you have an application that only hosts public data, a cross-site scripting is not really a serious thing. But if you have an administrational interface that lets you shut down machines or delete applications or reset the database, could be very harmful. There's a question?
I'm sure that everybody here knows what is XSS. Maybe we will talk about DOM-based capability, DOM-based tools and so on.
I don't think that everybody knows what cross-site scripting is, so no. I already talked to people, so I guess this is important to be on the same page, but it's finished now, and now the more complex stuff comes into play. So cross-site scripting is really a big problem, and we need to fight against cross-site scripting. And we need to have tools to detect cross-site scripting automatically, because manual inspection is a very tedious thing. And we created a tool to detect DOM-based cross-site scripting and to validate that a cross-site scripting vulnerability is really there. So basically, we have a 0 false positives rate. And when we look at cross-site scripting research, we see that there's a lot of research going on about reflected cross-site scripting. So almost all of the research papers are about reflected, persistent, or reflected server-side cross-site scripting, but there's almost no research on DOM-based cross-site scripting. And so we thought, well, we need to do something, and we need to look into cross-site scripting. And in this work, we see cross-site scripting as an information flow problem. So we first have some positions in the application or some situations where user data can enter the application. So for example, there are values in the URL where the application reads these values. And after the data is read, the data propagates through the application. So there might be some string concatenations on the data, or we read the URL and then take a substring from it, or apply some regexes to it, or split it up at some signs and extract the data. Then we might have some encoding in there. So we might have encoding functions such as escape or encode URI, and also unencoding functions. And in the end, user input ends up in a security-sensitive function, such as document write or inner HTML or eval. And at this place, we need to check whether the user input is encoded correctly. And if we are able to detect all of these flows, so from user input into malicious functions, and see whether these functions are encoded or not, we can actually detect suspicious situations in which cross-site scripting is happening. So our goal is to track all of these flows. And to do this, we implemented a taint tracking engine into the Chromium browser. So we took the open source version of Chrome and patched it to support taint tracking. And taint tracking is a system where we mark all the strings that are coming from user input with a certain marker, and then propagate this marker through the JavaScript execution engine. And in the end, when a security-sensitive function is called, we can check whether a certain string carries a certain marker and where it comes from. So we can see whether, for example, a call to eval is made out of user input. And here is a short example how this works. So this is, here we can see the general setup of the Chrome browser. So we have on the right side the WebKit rendering engine, which does the HTML parsing and the rendering. And on the right side, we have the JavaScript engine that executes JavaScript. And in the middle, we have the DOM bindings that are used by the JavaScript engine to query the DOM for certain attributes, because the JavaScript engine itself is not aware of the DOM. And now we have an HTML document, and the HTML document contains some script. So it initializes the V8 JavaScript engine with the script, and the script contains some content. And here in the first line, we can see the first statement of the script. And it creates a variable x, and it reads document location hash. And document location hash is some form of user input. So it goes through the DOM bindings, and the DOM tree returns the value of location hash. And what we do is, at this position, we add taint to the string. And we have byte-level tainting, so we do not only mark the string, but we mark each byte of the string. So for each byte of the string, we know where it comes from. And then this tainted value goes back into the JavaScript engine, and in here, there are some things happening. Concatenations, splits, regexes, and so on and so forth. And we keep the taint on the strings, on the bytes. So if one byte is copied from our string, we also copy the corresponding taint byte. And then it could be that we write back the tainted value to the DOM. So we also patched the WebKit engine to store the taint bytes. And at some point in time, we might read it again. So we might use this tainted value from the DOM to assign it to some other variable. And then there might be a security-sensitive function. So here, we could now, let's assume here is the document right now, and this could cause a cross-site scripting. And now we still know where this value y is coming from. We still know that it initially came from document location hash. So we are able to tell that there was a flow from user input to a security-sensitive function. And in total, we identified 14 different sources where user input can enter a JavaScript application on the client side. And we encode these 14 sources via an ID, so we give them a numeric ID from 1 to 14, and we encode them in 4 bits, actually. So we have, for each byte in the string, we have 1 byte of taint bytes, and we put in 4 bytes for the information where the string is coming from, and then we have another 4 bytes left, and we use 3 of the 4 bytes to store encoding functions. So we know that a certain byte flew through a certain encoding function. And here's a short example. So for example, we have here a variable declaration, and the variable declaration reads a value from location hash, and location hash contains this string, T, E, S, and a quote. And hash had the numerical ID 1, so in each byte of this string we write a 1, basically. And then we have some processing, for example, an escape, and this is the new value. So if we escape this string, the quote will become %27, and we will also reflect this. And you can see this here. So now the new value is 65, and this value is basically the 1, that is this location hash, and 1 of the bits for encoding that is set. So we know this is coming from location hash, and it is encoded with escape. And to do so, we patched all the V8 strings. So there is not only one string in V8, but there are server strings, there are slice strings, and 1-byte strings, and a lot of other strings. So we patched them all, and we patched all the methods, all the toString methods, all the split methods, and so on and so forth. And we also patched WebKit. And what we also did is we created a reporting mechanism from V8 and WebKit to an extension. So we built an extension, and this extension is able to get the reports out of the browser. And as soon as we have a security-sensitive function, for example, eval in the V8 JavaScript engine, or document write in WebKit, we simply call a reporting function, and this reporting function tells our extension that a flow was found. So we're now able to find suspicious flow. And we use this to conduct an empirical study on flows of websites. So what we did is we mounted this patch browser to a crawling engine. And the crawling engine is a distributed system, and it consists of several crawlers, and each crawler is our patch Chromium browser with a browser extension attached to it, and the browser extension actually loads URLs into the patch browser. So we execute the website, track the flows, and as soon as a flow is found, we report it back to a control backend. So we can crawl websites and then record all the flows. And we did so with the Alexa Top 5000 website, and we crawled the main pages of these web pages and the first level links. So all the links that we found on the first page, and crawled them also. And this amounts a total of about 4.3 million web documents. And we then detected the flows, and we were very surprised because we discovered about 25 million flows in this, from user input to security-sensitive functions. And this was really surprising that there are so many different flows. So this means that about 6 flows per site from user input into security-sensitive stuff.
So can I ask a question now?
Yeah, sure.
Okay, right. A quick question. When you talk about flow detection, will you just, for example, if there is branching in the code, and if it's never triggered, you miss that flow, right?
Yes, so we need to execute the code, actually. So if the code is not executed, we will not detect it.
Okay.
Yeah, that's a limitation. Okay, so we found 25 million flows, and we said, wow, what to do with all those flows? Are they actually vulnerable or not? And we figured out that not all of the flows are really vulnerabilities. So these are suspicious pieces of code, but there might be any checks. And therefore, we created a validation mechanism to validate that a flow is really vulnerable. And what we did is we created a generator that is able to create context-sensitive exploits. So it can detect in which context a certain payload is inserted, and can create a payload that exactly matches these surroundings. And the current situation that we are at the moment is that we have a taint engine, and the taint engine is able to find such a flow. But the problem is a flow is not necessarily a vulnerability, and one reason we can see here. So here we see there is some kind of user input, and the user input is written by document write. So this is a flow that we found, but the user input is validated. So we see a regular expression here, and the regular expression checks that there are only numbers and normal characters in this URL. And otherwise, if you put a payload into a location hash, this flow would never occur. Therefore, this is not a vulnerability. And another reason for why flows are not always vulnerabilities is that we also have server-side control flow issues. For example, we could have some kind of ID parameter, and if the ID parameter has a certain value, the server will echo a certain script or execute a certain piece of HTML or send that back. And this certain piece of script has the vulnerability here in document write, and the value, the user input, is coming from ID. But if we are tampering with ID, then this code will never be executed. So if you put a payload into ID, nothing will happen. So flows are not necessarily vulnerabilities. And our idea is to, yes, let's simply create an exploit, execute the exploit, and check whether the vulnerability is real. And to generate exploits, we first need to understand how exploits are generally made up. And exploits are context sensitive. And we have a lot of different contexts. And here's an example. This is a vulnerability with an HTML context. So we have a document write, and the document writes some HTML. And there's some user input incorporated into this HTML. So we see that we are currently in the value attribute, and to create a cross-site scripting exploit, we need to first break out of this value attribute by adding a quote. Then we are in the input element, and we need to break out of the input element with a closing bracket, and then we are able to open a script tag and generate alert 1. So here, this exploit is HTML. Another context is the JavaScript context. And this is, for example, present when we call eval. So when we call eval, a string is turned into JavaScript, and here we see a variable declaration to variable x, and the value is user input. And to exploit this, we need to break out of the variable declaration with a quote, then end the declaration in JavaScript, then call the JavaScript function, and then comment out all the trailing stuff that is in here so that the exploit is syntactically correct. So this time, the exploit is written in JavaScript. And here's another example. This is a URL context. So here we create an iframe element, and then we assign user input to the frame.source attribute. And the exploit would look like follows. So we would use a JavaScript URL and say, well, this is not a normal URL, but a JavaScript URL, and we would like to execute alert 1. So exploits are context sensitive, and we need to be aware of that. But what we figured out is that exploits generally have a common pattern, and we can see it here. And the first thing that we see is the payload. The payload here is in the middle, and what you see is the payload is always the same. So the payload doesn't seem to be context sensitive. It's just a value provided by the attacker. What we also see is the sequence in front of the payload, and we call this a breakout sequence because this is something. So, for example, if we are in an HTML attribute, we cannot execute JavaScript code, so we somehow have to break out to a situation where we are able to execute JavaScript. And then we see some characters behind it, and we call this a comment sequence. This is to get rid of trailing content so that our exploit is not being interrupted by some other hard-coded stuff that is behind the injection point. And if we look into the context sensitivity, we have to say that the breakout sequence is highly context sensitive. So it depends very much on the context. If you're in a JavaScript, HTML, or URL context, then the payload is not context sensitive at all. And the comment sequence is context sensitive, but only to a minor extent. So the comment sequence can simply be chosen. So we have one comment sequence for each context, and simply can choose the one we need to take. So the only thing that we need to do actually is to generate breakout sequences, context sensitive. And we created two generators for this. We created one generator for HTML context and one generator for JavaScript context. And how this works, I will explain now. So here we have the HTML generator, and first we check what are the different kinds of possibilities I can use to conduct cross-site scripting. So where can the injection point be? And in HTML, it's really easy. We only have 3 different situations where an injection point can be. So we can either be within a tag, so either in the tag name, in the attribute name, or in the attribute value. We can be a text node, so between 2 elements, or on the top level of the document. Or it could be a comment sequence. And the breaking out of these things is really easy. So if you're an attribute, we simply need to close the attribute with the delimiter used to enclose the attribute value. Then we need to break out of the tag. Then we need to close the tag. And then we have our breakout sequence. For text nodes, it's really easy. So text nodes are almost always able to execute JavaScript directly. There we only need some optional closing tags, and then we can open a script tag and print out whatever code we would like to execute. And comment nodes are also very easy. So we simply need, if we have a tainted value in a comment, we simply can close the comment and then open a JavaScript tag and alert.
I think there are some exceptions though, such as text area.
Yes, the
It doesn't fit to any of those.
text area is this one. Text area is basically.
Yeah, it won't execute though if it's within text area tags.
Yeah, but our generator is able to cope with this.
right.
So it is able to detect if it's in a text area,
Oh, I see.
and then it will
Anticipation
do this and
yeah.
add closing tags, and it will close the text area, and then you can execute the script. Okay, here's an example how this works. So here we actually see a vulnerability, and here we see the legitimate case. So in legitimate case, we call this URL with the location hash set to foobar, and this is the string that we see in our information flow tracking engine. So this is the flow, and we have the information that this part is tainted. Then we throw this into an HTML parser, and we will see that the tainted value ends up in an attribute. So we are in an attribute, so we need to break out of the attribute. We simply add a quote, and the quote of the attribute is a double quote. Then we see, okay, now we are in a tag, we're in the script tag, so simply close the script tag and also add a closing tag. Then we add our payload that we would like to execute, and then we have the optional comment sequence. And if you put everything together, we end up with this exploit. And we can simply execute it against the application, and yeah, it executes. So here's an example for the JavaScript context. This is seems awkward at first, but we saw a lot of this. So here somebody builds up a function out of a string, and it has a variable declaration and also incorporates some user input, and then it simply evals the code. And in this case, we have two different possibilities to break out of this JavaScript function. So the first attack would be the one above. So we could simply, we are in the variable x, and we could simply break out of x, add a semicolon, and then directly alert or put our code into it. So like this here. And the other way to exploit this is we can break out of x, then break out of the function test, and here, and then alert the one. And the two differences between these two breakout strategies is that the first one is very easy to create. You only need to break out of the last statement, then add a semicolon, then put your code into it. But the problem here is you need to rely on that test is really called. So in the first case, the application needs to call the test function, and it might be that it's only called when you press a certain button or something. And in this case, the breakout sequence is a little bit more difficult to create, because you have to break out of all the parent attributes and parent statements, and there might be a lot of if statements and for loops and blocks and so on. But if we put this into an alert, we will immediately see our alert window. So this is the strategy that we are using here. And here is again an example. So here we have the legitimate use case. We execute the web page at first, see the legitimate code. This is this one. So in X, there is the legitimate URL. And what we see in our taint tracking engine, that this comes from location hash. And what we do is we throw this into a JavaScript parser. And then we get this nice syntax tree. And what we do is, when parsing the stuff, is we give the taint to the parser. So at the end, after the parsing process, we still know which nodes are tainted or not. So what we see is that the string literal, which is example.org/test.html, which is missing here, that this is still tainted. And what we do is actually, on the next slide, what we do, we identify this branch that is marked in gray, and then we walk up this branch. So we start at the string literal, and then we would like to break out of the string literal. So we simply add the quotes of the string literal. Then we go up and find there's a declaration. And the declaration has to be ended by inserting a semicolon. Then we go up and see there's a block. And well, a block needs to be ended with a parenthesis. So we add this, and then we see, well, there's a function constructor. For function constructors, we do nothing to end it because you don't need to end it somehow if you end the block. And then there's a function declaration, and we leave it also empty. And this leads us to this resulting breakout sequence. So if we combine all these signs while walking up the branch of this AST, we end up with the payload. And we can put it together. So we have the breakout sequence, then we have a payload, and in our case, we simply use the reporting function. So we created another JavaScript function, non-standard function, that is in our patch browser, and we simply can call it and give it whatever variable, and we give an ID of the exploit that we executed. And then we add the comment sequence, and we have the resulting exploit. And then basically what we do is we build up a test case, and we create a URL, and then we simply call the URL with a normal browser, and then eval will see this code. And we see here first will create the function test, and then we'll create our eval payload. So with this system, we are able to create exploits and actually validate whether vulnerabilities are real or not. And then we employed it on the flows that we found. So initially we had 25 million flows, and then we decided, well, 25 million is a little bit too much because we need to execute one test case for each URL. So we need to serve to 24 million URLs. So we decided to focus on the interesting ones. And the interesting ones are the ones that allow you to immediately execute code. And these are the JavaScript and the HTML things. And then we said, well, we only want to have sources that are directly controllable. So in our system, we have a lot of sources of user input where a user might be able to influence the input, but this is not always the case, depending on how the application is structured. So with that, we only want to have directly controllable sources. And this is basically everything that comes from the URL and everything that comes from the referrer. And then we ended up with, in the first step, we ended up with 5 million flows. And from these 5 million flows, we had 1.8 million flows that were directly controllable. And from these 1.8 million flows, about 313,000 were not filtered at all. There were no encoding functions in there, and therefore we decided to create exploits for these 300,000 exploits. So we generated exploits, then generated the test cases, and we ended up with 181,000 test cases. And these were unique tests, so we had 300,000 flows that were suspicious, but many flows ended up in the same test cases. So if you have a site, and the site does 3 document writes and always writes a script tag, and the injection is always in the source attribute, you will end up with exactly the same payload and exactly the same test case. So we had 181,000 unique test cases, and we executed them, and actually we have 70,000 that were exploited successfully. So then went through and executed, and this is a huge number, but actually those 70,000 exploits are not really the 70,000 vulnerabilities, because you have sites that use content management systems or generate their code dynamically, and you have the same script code on every page in the site, so you will trigger one vulnerability a lot of times. And so we deployed a uniqueness criterion. So we tried to boil down to what are these, so how many vulnerabilities we found in total. And by applying this uniqueness criterion, we found 8,163 cross-site scripting vulnerabilities on about 701 domains. And these 701 domains do not necessarily belong to the Alexa top 5,000, because there are a lot of frames on these sites, and so we checked how many of these sites are actually in the top 5,000, and we ended up with 480 domains in the top 5,000, so roughly 10% of all the sites, and this amounted to 6,100 or 6,200 unique vulnerabilities in the Alexa top 1,000, so it's about 9.6%, or roughly 10%. And well, this number, I think it's really big, but it only represents a lower bound, because we only crawled the first level link of the application. We did not authenticate to the application. We didn't log into it. And our system is also not perfect in finding all the vulnerabilities. Okay, so let's summarize. So what we did is we built a tool based on Chromium to detect data flows coming from untrusted user input into security-sensitive function. We did a study and found a lot of flows, and therefore we created an exploit generator that is automatically able to generate cross-site scripting exploits to validate whether a flow is really vulnerable. And we found that in the Alexa top 5,000 websites, approximately 10% carried at least one DOM-based cross-site scripting vulnerabilities. And if you're interested in the topic, you can read our paper. So we have a CCS paper, and it's called 25 million flows, large-scale detection of DOM-based cross-site scripting. So it's basically the same name as the presentation. And there's also a bit.ly link if you would like to write it down. Okay, with that, I would like to thank you for your attention. And if you have any questions, feel free to ask.
You have already mentioned that in your experiment you didn't use any application and crawling was pretty simple. Yes?
Excuse me, I didn't got the last part.
You have mentioned that in your experiment you didn't use any authentication.
Yes.
And crawling was pretty much simple. So my question is, what do you plan to improve in your solution? And for example, to analyze logits and users' web applications like web mails and so on, because
Yes.
you know that it's much more interesting than trying to find on a single page.
Yes, yes, we're trying to improve on that. So we're
What improvements do you plan to do in crawling, and do you plan to do another experiment and scan?
So what we are currently doing, so we did a lot of crawls. So this was the first crawl that we did, but we did 3 or 4 others already. So we also have data for the Alexa top 10,000 web pages. We also did crawls now with level 2 and level 3, but there we need to decide which URLs we want to crawl, because it's just an explosion of state, because there are so many URLs, and on each level you have the effect of 100 approximately. So if you crawl the start pages, collect the link, you get 100 as many links as the start pages. If you then collect the links again, you have again the factor of 100 and so on. So it's really difficult to really crawl deep, but we're working on that. Another thing that we are doing, we added some basic some authentication stuff to our project, but this is still experimental and it's not really working well at the moment. But I think we'll manage it to also crawl some in some authenticated state. And what we also did,
My question about crawling was more interesting, because I'm not talking about crawling old-fashioned web applications. I mean crawling of such interface like RIA, Ajax, and so on. So
yes.
you can't simply crawl it by gathering all forms and so on. You need to make a whole map.
Sure, that's an inherent problem to crawling it itself. So crawling is really difficult, and especially Ajax applications are really difficult. So we are trying, on the one hand, to improve our crawler to be able to crawl such applications. On the other hand, we create a desktop tool for it. So we have a tool that is able to, where you can click and have a UI, and then you as a user can authenticate and use the application and basically collect all the flows.
And do you know that there is another very similar solution based on Phantom.js?
No, never heard of it.
From guys from Yahoo, I remember, they also patched WebKit, but in this case not Chromium but Phantom.js, and it's pretty good.
Okay, I'm not aware of that work, but
My question was if you know about it, and what can you say about to compare it with your solution?
I don't know it, so I'm sorry. Okay, other questions? Yes?
Thanks for the talk. I really like the part of the automate generation of exploit, because I think it's something was missing in the previous work. Concerning the tool you developed to detect data analysis and this scripting, it's very similar to Dominator, the work of
Yes.
it did on Firefox, but much the same idea.
It's a little bit different. So basically, I think he does not have, what we have is byte level tainting. So we can really, and this is important for the exploit generation. So what Dominator is able to do, it's tainting strings, but I think only on string basis. And if you only, the problem is Dominator has false positives. For example, if you concatenate two strings, one is hard coded and one is from user input, and then the string is flagged as tainted. Then you cut off the user input again and only have the hard-coded value, but if you had the flag on the string, so this is also a tainted value. So this is the one thing, and the other thing is the exploit generator needs to know the context where the injection takes place. And if you only have the string and one taint marker, you don't know where actually within the string the user input is. And we need to know if we are in attribute or if we are in JavaScript context in a function that is wrapped by an if statement and so on. So it's really important to have the byte level tainting. And therefore this is what Dominator is not able to do.
Yeah, Dominator is more for mainly testing.
Yes.
For manual testing.
Yes, exactly.
If you want to do something like you did without byte level,
Yes, exactly. Yes, and I think that there's an initiative. So somebody wrote me a message this morning, so that some Mozilla folks are planning to implement some kind of dynamic testing API in Firefox. So they're currently discussing about how to put stuff like this into the mainstream browsers and really into the code base, so that it's also maintained and works in other versions. Yes. Yes, exactly.
And the tools are available for download and is it open source?
Currently not. So we are currently working on that. There are some issues that prevent us from doing so. I guess there are a lot of licensing issues because we have a lot of different software stuff in there. What we plan currently is to release a service, so where you can put in your URL and it will crawl the URL for you. But you need to somehow prove that you are the owner of the site. So we would like to prevent people from using our tool to exploit all the sites. So you need to put up some proof that a domain is under your control, and then our crawler will crawl it for you and give you back the results. But this is still work in progress, and we are not yet at a stage to release it. But
So
I think
the feature is SaaS service.
yes, exactly. Basically, we ran it on the Alexa Top 5000, and there are some bug bounty applications in there, and we also received some bug bounty using it, but not a lot of it. I have the feeling that the bug bounty sites are very, very secure, and that there are a lot of people looking into. So we didn't find a lot of cross-site scriptings there. We found cross-site scripting on some Google domains, but those were basically sandbox domains that were meant to be used to prevent exploiting such cross-site scriptings. Yes?
I've got a quick question. When you patch the V8 engine and put all your tainting code and all, how do you deal with the Chrome updates in the V8 engine itself? So is it like straightforward, or is it really pain in the ass sort of situation?
Both, I would say. So the initial version of this browser was done 2 years ago. So I'm not really sure what the version was. And then we once ported it to a new application. So we do not support updates to Chrome. So we have our version, and the Ben who did most of the work on the Chrome side, he patched the new version in about 2 or 3 days. So it was possible, but he knew what he had to do, and he had all his patches, and he worked half a year or a year in this project. So and only looking into Chrome code. So he knew what he was doing, and he was able to manage in 3 days or so. But the new implementation is a little bit more complex, so I'm not sure how this will work out for new versions. Was another question?
Have you ever tried DevSnitch? It's a Chrome extension from Google. And I don't know if you ever tried it. It's really great. It allows developers to actually test their client-side code for DOM-based processes.
I have heard of it, but I have never used it. So
Should I try it?
yeah, sure, I should definitely. But because I think it was released after we created our tool, so we had also other work, but I should definitely look into it.
It's open for any developers. Anyone can use it.
Yeah, yes.
Try it.
Thanks. Other questions? No? Okay.
We need to, are there any more questions? We can
Thank you.
Great, your camera. Oh, well, some people decide to change their mind then. I know. Sorry? Yeah. I'll give people 1 more minute and then I'll start. Or tell me when you think I should start. Yeah. Yeah. I think, to be honest, it could probably have done with leaving an extra 5 minutes between talk. I mean, obviously, the same thing doesn't apply to lunch, but. Board such as there, I'll start. Is my microphone working? Yes. Yeah. Right, hello everyone. I might as well get started on time. I would just like everybody to admire, before we start, my beautiful PowerPoint presentation. And I will say that a significant amount of the time that I spent preparing for this talk, I actually spent writing the PowerPoint presentation because it's surprisingly difficult to actually get that live tile effect on it. So I thought I'd come in a little bit early and give people the opportunity to admire it properly. So first of all, a little bit of an introduction. I'm Marion McCune. I'm going to age myself here. This is the first time I've been back in Cambridge for like 20 years, and 20 years ago was when I was actually at university here. I've been working with Microsoft products back since DOS 3, which some of you may remember. One of my very first jobs that I actually had when I worked for an engineering company was to actually go around with a floppy disk that had the edit program copied off a DOS 5 machine to copy it onto all the DOS 3 machines because they didn't have it, so that's how far back I go. I'm director of my own security testing company, and you'll see at the top, that's my logo. I've been doing that for 3 years. Before that, I was actually the head of exchange for a big corporate. The less said about that, the better. And the things that I tend to do for a living are web applications, what people will call Microsoft stuff. I'm also very interested in mobile. I had the opportunity to attend the mobile training on Android and iOS earlier this week, and I've tried to it's actually given me some really good insights into how the type of applications that I'm going to talk about today actually not only fit into the traditional Windows world, but also a kind of what I can almost describe as Microsoft's take on slotting in a mobile ecosystem into their desktop infrastructure. And I think that's particularly interesting with what I've called universal apps, which have just been announced that I'll come to next. Here's my rig at home. I couldn't resist it. I like Surfaces. This is a Surface. Let's hope it all doesn't go wrong this time. There's an Xbox One in there somewhere as well. And I get to live here, which is Loch Goilhead out in scenic Argyll, and I get to test websites for a living, so I consider myself to be quite happy in that respect. So what we're going to talk about today, this is just an introduction to Windows Store apps from the point of view of the kind of testing that we would be asked to do here in the UK. So I'm a tester rather than a developer. You'll see my attempts at developing a Windows Store app later. It's not very good as yet. But what I'd like to make clear from the start is this isn't a kind of like a red teaming approach to this. This also is not, you know, I've got 6 months to study and analyze one of these apps and really analyze them from a Windows perspective and perhaps start attacking the Windows kernel and hoping that Microsoft will give me £250,000 to do it. This is literally, you know, I've been told by my testing company, you've got one of these things to do, and you've got 4 to 5 days to do it. So, you know, you better just get on with it. And often people, I found this myself because I test a lot of things that I don't know anything about. So this will give you an opportunity to just see whether things are actually located. As a matter of interest, how many people here are actually testers? Most people. Developers? I shudder to ask this here. Anyone here developed Windows 8 apps? Oh, good. Oh, good. Good. Right, so first of all, I'm going to give you some background. Then I'm going to introduce the Windows Store and show you some apps. Then I'm going to talk about the security architecture of them. I'll talk about the Windows runtime, which is what these things are developed to. I'll talk about the sort of development environments that you might expect to see. I'll talk about store requirements and certification. And then finally, on this section, I'll talk about the Microsoft testing process. And then I'll jump on and actually start talking about how you would test them. So I'll try and go over this part quite quickly. So firstly, just a little bit of background to this. How many people use Windows 8 at home or in anger? Or a disappointingly small proportion, never mind. So back in the day, when Windows 8 was first being developed, all the talk at Microsoft was around Metro apps. And this is the story behind the title for this talk, which is Metro Down the Tube. It's also my T-shirt. Because the way that Microsoft was supposed to have developed this design language is it was all supposed to have been based around the Metro signs in Seattle, which is obviously right next to Redmond. And the kind of cut-down, sparse design that it's got was supposed to reflect these designs. It was actually quite interesting because someone showed me a screenshot this morning of some of the work that Google have been doing and some of the stuff that's come out of their conference this week. And I believe somebody made a comment that I think Microsoft must be doing something right because everything on the web all of a sudden seems to have this flattened kind of Metro look. So they are now calling it the modern design. And the apps actually sort of, are based on it are now called Windows Store apps. And I think that the reason, though Microsoft had never officially admitted it, as far as I know, was that sometime very, very late in the process, they actually discovered that they were infringing somebody else's trademark by doing it. And it was also somebody else's trademark that they did a lot of business with. So they couldn't just say, sort of brush it under the carpet. They had to go ahead with it. So now it's actually quite funny. I don't know whether people ever watch any podcasts or anything done by Microsoft, but you'll find people quite a lot. They start to say Metro, and then they stop and have to go back and start saying Windows Store apps, which is rather like listening to people talking about Bing. So you see the tube is closed. That was the other part of the talk. So the Windows Store, back in 2012 when these things were being issued, Google and Apple already had a store. So the huge temptation for Microsoft must have been to say, right, we need a piece of the action like this. We need to get a whole lot of developers 30% as well. I actually think, maybe I'm being a little bit charitable here, but I actually think that there was a deeper purpose to it than that. Because one of the things that sort of, that you'll notice, I mean, the internet has become really a bit of a sewer. And there you've got sort of, an attempt to look for something that I deliberately knew would pull up a whole lot of nasty links. But really, it has got quite bad, and it's particularly bad if you go and search for Windows binaries out there. I'm not being sexist or ageist here, but I would say that I bought my mother a Surface RT because I wasn't really happy with the fact that she was going out there with a full-on Windows laptop and, like looking for binaries. I was worried about she would find them. Any kind of search that you look for now on the internet that basically says free software for Windows, exe files, it's just an absolute recipe for getting malware. And I believe that the search Emma Watson was supposed to get the most likely to get you malware, but then I believe it was changed to Lily Collins. So you can go figure. But I imagine that if you actually went to a lot of those links that are on that page and the following pages, you're going to get yourself a nasty piece of malware. So basically, Microsoft introduced the App Store, and it's very similar to Apple Store or to the Google Play Store in the sense that it's supposed to be a secure marketplace where you can either acquire free apps or you can pay for apps, but what you'll not acquire yourself is anything nasty to take home with it. So the apps obviously range in quality and quantity. There's been a horrible rush to the bottom on these app stores. I really honestly blame tech journalists for it. To my mind, it is better to have 50,000 quality apps than it is to have 1 million, really crap fart apps. And the trouble, certainly with the Windows Store, I'm not look at the other two all that very much, but at one point they were like offering free Xboxes and things to people that develop. Bad plan. Because what people have done is they've, sat down and it's quite obvious, I'll develop myself a free Xbox this afternoon, and there's a load of rubbish in there. And I don't think that the situation on the Apple and Google side is any better. So you can see there are games and things. There are also utility programs in the store. All kinds of different things, file managers and DVD players and so on. You need to be very careful with them from a tester's point of view. I'll come back to why in a minute, but I'm not expecting to see a proper Nmap clone in the store anytime soon for reasons that I'll go into. And if you do see one that you think might be useful for that kind of thing, I wouldn't, because you'll understand why once you understand the limitations of these things. So first of all, the security architecture of these things, they're very different to an ordinary Windows 32, a Win32 application, because for a start off, they run in a sandbox. And the best analogy that I've got for this, apart from saying that anybody who's familiar with mobile would be also familiar with this, is that I've seen it compared to the difference between guests in your house and guests in a hotel. So if you've got a guest in your house, they can come into your house and they're maybe just invited to the bedroom. But while you're out, there's nothing to stop them going and having a riffling around and, you know, look in your bottom drawer, you know, go and empty out your drinks cabinet, pull the posters off the walls, go and have a pee behind the bed. And when they're gone, there's no really good way of seeing what it is that they've done or getting rid of them again afterwards, because they've just had the whole run of the building. Whereas as against that, in a hotel, what you will actually have is they're restricted to one room, and there's a process for cleaning that room out once they've gone. So the chamber person can come into the room, clean it all out, everything's gone, you're back to where you started. So that's the concept of a sandbox. And in the context of Windows Store apps, this is called the app container, and we'll see later on some apps running in an app container. And this ties in with another Windows concept, which is relatively new and hasn't got a huge amount of publicity, or not as much publicity as I would have thought it would have had, which is integrity levels. And basically, integrity levels, very quickly, if you are running as an ordinary user in Windows, you have a medium level of integrity. And the idea of the thing is that you cannot disrupt other processes which have a higher integrity level than yours. So if I'm running as a medium level process, an ordinary process, I can't disrupt or touch something that's owned by an administrative process that runs at high integrity. So these store apps will run at a very low integrity level, which is the kind of thing that you see if you ever run Internet Explorer in enhanced protected mode. You would exactly see it, and you will see the same thing if you run Word. I don't know if anyone's ever opened a Word document, and it comes up with the bar along the top saying, you're opening this from an untrusted source. Well, if you actually, while you've got Word in that kind of mode, if you actually go into something like Process Monitor from sysinternals, and you actually add the column for integrity level, which we'll see in a minute, you'll actually see that at that point, Word is running as a low integrity process on machines that can't do anything outside its little sandbox. As soon as you click on Word and you say, right, okay, I want to trust this thing, I want to, you know, I want my macro virus or whatever, I'll click on Enable, and you actually see it, and it will come up to whatever integrity process level Word normally runs at. So here we see the architecture of these things. So the application, while it's running in its sandbox, it's only really got access to two areas. One is the area where it's installed in, and the other one is it's got a special area which is underneath your actual username. It's got two directories, we'll see in a moment, and it can write to those, and it talks to system APIs only through a brokered process, and then only in a way that's actually declared in its manifest. And the way that this works is that it must sound as though these things are really, really, really limited, because I'm saying they can only do very limited things. And with Windows 8, we've moved to having like nice devices, I think anyway, like the Surface, which have got a lot of cool features. So they've got microphones and webcams and all these things. And by default, these apps can't talk to any of these things, so you'd think they're a bit crap, really. But no, because what they have is capabilities, and capabilities have to be declared in a manifest when you're developing them. And capabilities are things like the ability to talk to the internet, the ability to use the webcam, the ability, for example, to use your contact details, your location, proximity sensors, all these things. And not only are those capabilities have to be declared by the developer, but they are also listed in the store before you actually install them. So if you're a canny kind of user, when you go into the store, you will see that there'll be a list next to each app saying what capabilities it's actually requesting. And then when you actually use the app for the first time, it'll prompt you again. So it's no good to say, sort of, right, I've installed it and I've forgotten about it. Then when it comes up later on, you actually run it for the first time, and it wants to use the webcam for the first time, it will actually flash a big purple box, which people may have seen, onto the screen. And at that point, it'll say, can I use the webcam? And so it's like a kind of belt and braces approach to it. There's also the concept called a contract. And a contract, I don't know whether you've seen it, but when you go use the share charm down the right-hand side of the screen, you'll notice underneath sharing, there'll be a list of applications. And those are basically applications that have declared a contract. So they've said, for example, me, I can handle JPEGs. So then when you actually open a JPEG, or go to open a JPEG, you will see down the right-hand side a list of all the applications that have made a contract or attempted to make a contract to handle JPEGs. So how are these things? What runtime do they use? Well, it's not like this. I couldn't resist getting another picture of a Surface in. That's a Surface RT. Microsoft caused a huge amount of confusion over the Surface RT by calling it a Surface RT. So the name of the device was effectively the name of the runtime, which is WinRT. And what WinRT is basically is a platform where you have to develop to the Windows runtime. And the main difference, I suppose, between the runtime and other application frameworks is it is very cut back, so you can only use a subset of APIs. And the most obvious restriction in that respect is where a traditional Windows 32 or a Win32 app could talk to, for example, straight to a database, open up a socket and talk to it. In WinRT, everything goes over HTTP requests. So one of the things that you'll see later on is that these apps written to this framework have got a lot more reliance on web services and that kind of inter-process communication than a conventional Windows app will have, because they can't have the kind of raw access. And this is why I say that, here we can have a more interesting picture for people to look at. This is the kind of general architecture of the thing. So this is not a replacement for Win32. I don't think Microsoft themselves would even claim. I mean, in fact, I think they said the other day that there will never be Visual Studio that is written as a Meta app. So you're never going to see something where something of that level of complexity is actually developed in this kind of Meta style. The other thing about WinRT is that it's deliberately designed to be asynchronous. So an awful lot of the JavaScript calls that you'll see, they assume that things aren't going to be very instantaneous. So they'll go in and work on things in the background. Very early on, I actually had a troll through the store. I thought to myself, I'll see what kind of thing that I would be interested in can you develop using this runtime. And I came across an app, which I won't actually mention the name of it, but it looked as though it was a kind of Nmap clone. And I thought, oh, this is interesting. And I did some kind of Nmap type functionality with it, and it appeared to go out and do it, and it appeared to return results. And I thought, oh, this is quite good. And I wonder how on earth it's doing it, because the point of this is you can't mess with it on a protocol level. What I actually discovered that it did was it actually went out and it went to the web service, and the web service went to another server that was out there on the internet, and that was essentially running Nmap. Now, to any tester that has, you'll probably notice what the obvious problem with that is the sense that it wasn't coming from your IP address anymore. It was coming from somebody else's IP address out on the internet. So if you ever want to use any of this kind of app for testing, you need to be sure of what it's doing. Here you can see actually on the picture, Microsoft are leading into this idea of universal apps. So this was actually something that was launched very, very recently in Build. The idea that you can develop once using Visual Studio you can develop on the Windows platform, and it will develop for Windows Phone as well. And I think that's just the beginning. I'll be somewhat surprised if next year they don't bring the Xbox into the fold, and you actually discover that with Windows 9 you can develop one application that will run on everything from a 4-inch screen on a phone right up to a 15-inch screen on a television set. And to me, that's quite a cool, interesting concept. Development environments. These are the different things that you can develop with. So effectively, there's 3 sorts of app, of which one that you won't see all that very often. And these are the percentages that you'll see of them at the store as of about 3 months ago, which is where I got these statistics from. This is quite interesting to see, or quite interesting to me, because I think that Microsoft were trying very hard to push the idea that all these things were going to be developed in JavaScript and HTML. They've produced an interesting series of apps themselves, which are quite good to the Bing apps, if you want to look at how these apps hang together. And I think they had this idea that JavaScript was going to be the big, enormous platform for them. But I think that the developer base has wanted to stick with obviously the deeply traditional C# developers. So you see a lot of apps there out in the store when you go and look at them. and you think to yourself, God, that would have been crying out to be a JavaScript app, but no, it's written in C#. So people like what they know. It never ceases to amaze me, the number of things that people think will be a good idea to push into JavaScript. I mean, I know there's a book called JavaScript, The Good Bits, and it's like that thick, and then there could be JavaScript, The Bad Bits, which is that thick. Yeah. And at this point, when you actually get to the point of starting to develop, you'll notice that when you fire up Visual Studio and you choose a template for a store app, at that point, it will ask you, do you want a license to develop? Because you need a license to develop from this point of view. And literally at this point, all you need to do is click OK, and it will go out and do it, and it will verify that you have a Microsoft account at this point. But to be honest, the Microsoft account could be testuser.idon'texist@outlook.com. You can just make up an account name. So at this point, the evil empire don't need to know where you live, but they will want to know where you live at the point where you actually submit an app to the actual store. And what your license to develop will at this point give you is it will give you the ability effectively to sideload apps onto your machine and to run them onto your machine. Because normally the only avenue for you can't get one of these, develop it, and then give it out to 16 of your friends. You can package it up and give it to other developers, but they also need development licenses on each one of the machines that they're going to use for it. So you can exchange it to a limited extent for the purpose of testing, but you can't actually sort of just hand it around and bypass the store altogether in that respect. And here you can see Blend for Visual Studio. Two very useful tools to get before you start testing any one of these. One of them will be Visual Studio Express, which is free, and the Windows 8 version. And the other thing which comes with it is Blend, which is also free, and actually, completely coincidentally, is also a super cool tool if you're not a really great HTML developer and you want to draft up cool-looking websites for doing phishing attacks and things like that. It's quite cool. So the store requirements and certification. Once you've actually got the app, or once the developer has actually created the app, he will actually package it up. And while he packages it up, he will actually create the app manifest, which lives in the top-level directory. And that's the thing that I was talking about earlier, which contains the list of capabilities and requirements for the app. And there are lots of requirements at that point. If you want to read up on it, there's a Microsoft documentation as long as you're armed. I don't think they keep to the requirements all that very well. You keep seeing things about, the developer has said that this application meets with accessibility requirements that can be used by everyone. No. Yeah, so they're not. I think a lot of the requirements there are largely brushed under the carpet, and also content, because you're not allowed to have kind of 18 rated content in these things, apart from for certain games. And then you give it a whack, as they call it. This is the Windows certification kit. So effectively, this is something that when you think that you've got it ready, you run it through a pretend deployment process on your own machine, and you'll see whether it actually passes. If it does pass the whack, it can still fail the store for various other reasons, but they say that they will tell you why it has actually failed, if it passes whack but fails the store. The other day there was a lot of chat around what Google and Apple actually test for in the stores. I think Microsoft, in a way, are stricter than either of the other two, but in a number of ways are less strict than Apple, but more strict than Google, so they're somewhere in between the two. So most of the stuff that they'll actually do are what I describe as like old-style security tests. So, for example, they'll test all these things with their bin scope analyzer, and these are mainly headers that if you've developed in Visual Studio will automatically be there, which is why later on that they actually tell you to develop in Visual Studio. So things like SLR and things like DEP, and they'll make sure that all these things are turned on, and they'll make sure that you haven't sort of set things that you haven't ruined the registry, and that you haven't set your executables up in the wrong way and all that stuff. And last but not least, very importantly, they'll give it a check to make sure that it is not malware. And they'll also give it what they describe as other testing as well. So when you actually submit it, you have to give them notes to testers, so that they will actually know what the application does. And I believe that if you have certain categories of application, that they'll actually give them like increased scrutiny. So if you say I'm a banking app, or I'm a secure password app, they'll look at it more. I've looked at some secure password apps, and I didn't really see a great deal of sign that they've been hugely, greatly tested. So all this is really good stuff. And up until now, I'm actually feeling like a warm, fluffy feeling about these compared to traditional Windows apps, where basically you just go and you get them and you grab them. But there's always a but. This is a really good presentation. There's not much stuff on the internet about Windows Store apps, but this is one. This was done by some guys at Trend, and it was done right back in the day when Windows 8 was in preview. And what they actually did was they went and gave the store apps a good going over, and they came up with a few things. Basically, the conclusion that they came from was that from the point of view of binary applications, these things are actually quite secure, because when you're actually attacking them, you're attacking the sandbox, you're actually attacking Windows itself, you're attacking either the kernel or you're attacking COM when you try to break out. And that's actually quite difficult, because Windows has obviously been a piece of software that's had its fair share of attacks over the years, and it's pretty... I don't think that anybody who's doing a 4-day test on an app is going to be able to get through that kind of security. Defeat malware. But what you have to ask yourself is, what actually are we looking for here? Are we looking at just protecting the operating system? Or are we looking at protecting the back end of the application from a malicious user? Or are we looking at protecting user A, who is an innocent user of an application, from user B, who might not be so innocent? So hold that in your mind, and I'll come back to that in a moment. So quickly, security testing these things. Where are they? The way that we were, testing approaches, software setup, JavaScript, decompilation, web services, and some lessons from another country. I'm going to have to be quick here, aren't I? So first of all, where are they? C, program files, Windows apps. You won't see it there by default. First of all, you have to put show hidden files and folders on, and then you have to go to the security tab and take ownership of the files, and then you have to take control when prompted. And at this point, you could almost think that Microsoft didn't want you seeing this stuff. But when you've been through all those, and you have to be logged in as an administrative user to do this. And when you've done it, you'll see these, and these are the different package names. And underneath each one of these is a series of directories. And from the series of directories and the nature of the files that are in them, you can very easily see what type of app they are. In other words, whether they're a .NET app or whether they are written in JavaScript. I was going to write a little utility to do it. Most JavaScript apps actually have got a directory underneath there called JS. At this point, danger, Will Robinson, danger. The nature of these things is, if you're going to test them, don't test them under your own user ID, particularly if you like your Microsoft account and your profile. I started testing, and one of the things I messed around with was the Bing app, and I was trying to change the bypass signing on it. And not only did I break the apps on the machine I was on, but with the nature of the thing, they synchronize back to your profile in Microsoft Cloud. And then you can actually, if you log on to a different machine, the problem goes around with you and follows you. So you can actually, you log in and your app works for another 10 minutes, and all of a sudden it stops working in the same way. And I actually locked myself out of these things for quite a long time. So just make a pretend account, as I said earlier. The way that we were, if you'd gone to try to test these things over a year ago, you could have done some really cool shit very easily. So you could, for example, you could have taken an app that was proprietary and secret, and you could have gone in there, and if you knew what you were doing, you could hack around with it, and you could turn it into My Evil Hacker app just by going in there and changing the JavaScript and HTML. And then, if you wanted, you could have turned it into a nice open source app that was free and healthy and everything. Unfortunately, they've closed most of these holes off over the course of the last year. So it's now, these apps have got Windows resource protection on them, and they're really difficult to actually modify, they're very difficult to get them to modify through Windows. So now what you can actually do, the obvious way to do this is to actually, you can't directly go in there and change that directory and change the code in it because it won't let you. But you can go and you can mount that file system in Linux, and you can go and you can change it, and you can change all the pictures in the app to pictures of kittens or do whatever you like. But unfortunately, when you go back into Windows and you start the thing back up, it checks the signature as soon as the app starts to run, and if there's even one byte of that's changed, it just won't run at all. There is a mechanism for developers, for paid apps, to actually verify back to the store to make sure that they're real. and that got hacked at the end of 2012, but it's been fixed now. So now the security of these things very much is down to sort of the individual app. So in other words, it comes down to testing the individual app and not the security of where it's sitting within Windows. Testing approaches. I wouldn't be bothering with, this is how I'd go about it. I wouldn't be bothering with these things with trying in a short period of time to attack the sandbox. You can treat them as web applications. You can look for local data on them, and as I said, there's two places that gets created. You can do decompilation and code review, and that's made nice by the fact that you can actually look at the code for them. And as I said earlier on, these things have an unusually large reliance on web services, so you can actually look at attacking that. Software setup goes without saying you need a copy of Windows 8 or Windows 8.1 to do this. They won't run in Windows 7. I don't think there's any way of doing it. Slightly surprised me. They will run on the server operating system, but you have to have the desktop experience pack actually installed on that. Here you can see sort of the Fiddler web debugger and proxy. I am normally a burp user, like most professional testers, but I think that these work better with Fiddler for two reasons. You'll notice that there's a Windows 8 config button up there on the top left. That's really important. By default, and as a security measure, these apps won't talk to the local loopback address. Obviously, you need them to do that unless you've got a funny setup with if you're going to run your proxy on the same machine, you need to have them do that. And if you click on that button, then it will actually give you a choice of which ones do you want to enable or disable. You can do it yourself with PowerScript or any other scripting languages, but that makes it nice and easy for you. This is also free, so you don't run it. Well, obviously, you get free versions of Burp as well. And then decompilation tools for .NET or disassembly tools for .NET. I personally use .NET Reflector. I find it very stable and very good, and it costs a little bit of money. There's also .peak, which is open source and free, but keeps crashing my machine, or did back then. And here you've got sort of, so this is the dialogue that I was talking about. This is how you actually disable the app container loopback exemption, which you need to do before you start. So on these JavaScript and HTML apps, these are really web applications, and you can on the whole treat them as such. They have a concept called local context versus web context, but I never understood too much until I came to compare them to the way that Android works. And this basically means that local context is any web page that is actually declared and loaded up in your app manifest. So that's local. And remote context is, web context is anything apart from that. So the difference between the two is that anything that runs in local context can actually effectively access the machine. So it can access the Windows runtime on the machine, the registry, the devices, everything. But as a security measure, when you do that, anything that can damage the DOM is automatically filtered out, so you can't effectively run remote scripts on it, so it just blocks them. And whereas web context is different to that, so you load up other web pages in the web context, and they can run scripts and things, but what they can't do is access the Windows runtime. And all these apps actually run as a headless version of IE, and when you look at them, you can see them in Task Explorer as WWA host, which I, for reasons that are just mine, called the WA host. It's quite interesting because it's nice when you're testing them because you only need to worry about this one browser. You don't have to worry about, right, okay, God, I went and tested it in Chrome and I got this nice cross-site, I can't get cross-site scripting on it in Chrome and say, but God, I didn't try it in Firefox and I didn't try it in IE and I didn't try it in 14 other browsers that I've got in different versions. Well, these things only run in IE, so you don't have any choice in the matter. And these apps, they suffer, I would say, once you actually get into testing them, from the typical problems that apps with a good framework suffer from. So in other words, they don't tend to have like awful problems, like for example with cross-site scripting, like really overt problems with it. But what they actually do suffer from is all the things or can suffer from, other things that frameworks don't help you about, so that they're not immune from, for example, from authorization flaws. The other thing that so it's possible to get cross-site scripting with them, but the developer actually has to work at it a little bit. It doesn't just sort of, oh, I'll do nothing, and I'll have the cross-site scripting problem. On the whole, if you do nothing, you won't have it. one thing I had to mention was SSL, because I noticed that a lot of the Android and iOS people were talking about this. By default with these things, if you use SSL, you must be a valid certificate at the other end, because the default behavior for them is that if the certificate, if they hit a certificate and it's not good, like it's expired or it's the wrong name or it's self-signed, it will just bomb out and it'll just close the app, because that's what these apps do. So there was a lot of complaints about this, because a lot of companies and apps, they like to use these self-signed certificates. So now you can use a self-signed certificate, but if you do, you have to bag it up in your manifest so that the app actually knows about it. And here we can see a picture of Task Manager, and we can see the WA host, and these are all different apps that are running. And like good citizens, when they're not running, they after 5 seconds they'll suspend themselves. When you go into desktop mode and you've left 14 store apps opened on your machine, you'll see them all sitting there and suspended. That's actually one of the things that gets checked for. If they don't suspend nicely, then they don't pass their certification. And here you can actually see that what I was referring to earlier, which is that the WA host runs as a low integrity process. So while these things are running as low integrity processes, they can't easily break out their sandbox. Decompilation code review. .NET apps, as everyone knows, these can be trivially decompiled. You can obfuscate them. And at this point, once you actually get them decompiled, you just right-click on them within Windows Explorer, and you can say to it, right-click and open the executable or open the DLL in .NET Reflector. And once you've got it open, then a lot is going to depend on your ability to read the language. So typically, web testers can read JavaScript quite well. Typically, also, they may or may not be able to read things like C#. So some of the things that you're actually after, even if you can't actually read the language, you can look in there, and you can look for things like credentials and keys that maybe you could attack web services with later on. You can check things like developer mode. You know, have they got developer mode on? Have they got test mode on? I don't really have time to go into this in great detail. One of the things you used to be able to do, of course, was you would be able to modify the app. So if it had like admin mode equals false, you could change it to admin mode equals true and see what happened. And you can't directly do that anymore. What you can do if you feel fancy about it, I'll write a blog post on how to do this, is you can actually copy all the HTML and JavaScript out of one project in Visual Studio and compile it as a new project with the same name, and then run it on your machine, and then actually change it that way. And you can, that's quite a good way when you're actually testing these things. If you've not been given the source code, if effectively all you've been given is like a kind of like a blank canvas to it, that's one of the ways that I found of getting around it. And SSL, you should be looking for this last statement here, because that's the statement that actually forces SSL in the use of SSL in this kind of app. So if it's not there, that means it can talk in clear text. Bad coding practice, I won't go into these. Eval exec, I like that one. MS exec, unsafe local function. So actually, if you're going to write an unsafe function, it makes you realize that you're writing it while you're writing it. One of the things you can do is grep for unsafe. Untrusted dynamic content, and this is just the normal stuff. Local data I mentioned. Apps, as well as the package directory that they're installed into, they can write to anything under the package name. So these are good places to actually go and look. And there are two directories under there of interest. One is local state, and that's what happens when you, if you like, for example, I'm working on a tablet and then my boss comes past and I'm playing Mahjong or something, and I close the tablet, then the state is saved into local state. Remote state is because if I've got, these things are supposed to roam. So I've got two tablets and my boss gets one and I close it. I want to be able to open it up onto another and instantly restore it. So that puts it into remote state. An interesting piece of research would be, I don't think Microsoft have ever stated exactly where this remote state goes. It's somewhere on their cloud. Web services. The attitude of most developers to web services is the fact that if users don't see them, they're not there, and they don't really need to worry about the security of them. And you do, as I'm sure all testers know. So here's a web service that I tested earlier, and I'm sure everyone could tell that it had SQL injection in it. As I said earlier, these things, because they're very limited in the way that they can make RPC calls, and they're effectively limited to HTTP, they make a greater than normal use of this kind of thing. So it's always nice to try to find the back end and have a look at the little APIs. So also some lessons from another country. Anyone who's familiar with mobile will have seen that these things are actually really very, very, very similar to mobile apps. This brings me very nicely to the OWASP Mobile Top 10 because this is obviously very, very, very relevant. And to turn it on its head slightly, these are the recommendations that Microsoft give for developers. So as testers, what we should actually be doing here is we should be making sure that the developer has actually done this, or in other words, looking to see whether he hasn't. So things like minimizing the app capabilities, don't trust remote data, that's obviously sort of, obvious. Authentication, that's one that by default, these things will say they'll use the Windows credential locker or a Microsoft account to actually authenticate with, but you can use all kinds of other things. You can use OAuth, you can write your own authentication schema if you want to. So that's a really good thing to look into. And possibly one of the most important things, don't play around with the mechanisms by which the WinRT is segregated from the internet. Otherwise, you really will make yourself problems. Or turning it around, sorry, I'm talking to developers. I'm not talking to developers, I'm talking to testers. You need to look to make sure that the developer has not screwed around with this, because that is somewhere that you really will end up with problems. So the obligatory, just before I finish, OWASP project for this, I've written, or I'm starting to write a little training application to assist developers and testers with this. And there's a web goat, and there's Rails goat, and there's Droid goat, and I discovered this week that there's iGoat as well. So I thought we'd had more than enough goats around, so I thought we'd have a store sheep instead. This is store sheep, and store sheep is called a friend for you. You is a sort of joke. And store sheep is going to be a dating agency for sheep. So basically what you can do is you fill in your own profile, and then you fill in the profile of your sheep, and then you can, later on in the whole process, you will get the opportunity to have your sheep meet up in the cloud with other sheep and compare their experiences. And along the way, you will find some hideous security vulnerabilities. So I'm kind of working on that at the moment. It's just an alpha at the moment, so you won't see anything very interesting on it. Those two buttons are just me mucking around with IndexedDB. So I was going to, if there were any Windows 8 developers in the audience, I was going to say that any assistance on this would be greatly welcome, because I'm not a developer. I'm just learning on all this stuff. But I hope that we'll actually work on this and actually be able to get a good project. In conclusion, are these things actually secure? I said I'd return to this subject. Well, in a way, yes. Yeah, I'd say they are secure. They're a huge improvement on traditional Windows binaries for all the reasons that I've gone into. And frankly, if you get ordinary non-technical users and you say to them, where would I rather that they were going to get their software? Would I rather they were going out onto the internet and acquiring malware and all those things, or going to the Windows Store and getting these things which, although some of the apps may not be, absolutely fantastic, they're at least you're not going to get a virus from them, or at least there've not been any recorded instance of it so far. And Microsoft are really trying hard to make them secure in that respect. But my husband says that there's no such thing as he's also my business partner, which is why I mentioned this over. Because in a way, these things are, Microsoft cannot make these things secure in the way that maybe a lot of users presume that they are, because for the majority of these apps, or the ones worth their salt, they've got to be web applications. They're going out there and they're talking to the servers at the back end. And if you've got a web service that is the majority functionality of some of these apps, it doesn't make any difference that if it's nice and secure on the client, if it is hideously secure on the back end. In other words, if it's got SQL injections in its API, you can't expect Microsoft to go out there and be testing, your web server. You wouldn't want them to, and they couldn't, because so you might have other things that are pointed against that. So developers and testers need to make absolutely sure that they know when they're going into testing these things what the limitations of the security model provided by Microsoft are, and where they actually need to break out of that and actually start testing themselves. So I'm afraid I'm going to have to leave this with a great big enormous resounding maybe. And like most things in security, I suppose whether they're secure or not really depends on your terms of reference and your definition of security. Questions? Questions? No questions?
Sorry.
Oh, go for it.
You said because they're scripting these apps, is it the same risk as it will be in a web application, or is there a system call you can make from the headless, i.e.
Sorry, I didn't catch the very first line.
is the risk higher in next test, is the risk the same as an OAuth, or is it higher in
Well, I would say you're less likely to get it because you have to actually quite work as a developer to get it, because it's like SP.NET. It's got, like, I suppose, the equivalent of like an enhanced version of request validation. Plus, because it runs in a new, secure in as much as it stands, version of IE, you're not having to cope with people who go in there and do it with IE8 or IE6 or something like that. But I don't think that if you actually deliberately go and break that model, yes, you can get cross-site scripting with it, but I would say you're probably less likely to get it than you would with a conventional app, if that makes any sense. Oh, go for it.
Is the security architecture the same for a mobile application as it is for a tablet or Windows 8 application?
Well, the phone is slightly different at the moment, and this is really about the this would be for everything from like an 8 or 10-inch tablet right up to any Windows PC that you've got, and also really the same on an RT or Windows RT devices. It would be on a full-on Windows Pro 8 device. The phone is slightly different at the moment, but it's not. When you build one of these new universal apps with it, which I just need to start looking into, it will be exactly the same on the phone. Well, within the limitations of the fact the phones are smaller, as it would be on the full-size app. So at the moment, very slightly different. In the future, they won't be any different. They'll just have the same security model.
Do you have any recommendations for testing like a specific mobile phone application? The problem that we encounter usually is that you cannot get root access or like administrative access to a phone so you can actually play around with the application. Do you know anything that you can do to bypass the restriction?
It's funny, I was talking to somebody about that the other day. It's exactly the same situation, really, as you get with an iPhone, where you don't have, if all you've got right is a really new version of the iPhone and you haven't got a jailbreak for it, then really you're stuck with doing things like, for example, you can look at the bits and pieces that it actually does expose on the phone, and you can test it as a web app if it's got a back end to it. And you can attach Visual Studio to it, and you can look at things like the processes, but what you can't do is just go in there and actually have a play about, and that's both a limitation and a strength. It's good from the point of view of the fact, well, there's no jailbreak, so you don't have to worry about, what if people use a jailbroken device, but on the other hand, it's bad from the point of view of, you can't, it's difficult to then say to the customer, it's secure, and then there's a jailbreak 2 weeks later, and then so that is actually a problem in that respect from that point of view. No, okay, thank you very much, everyone. Thank you for listening.
Don't leave. I swear I'm going to do really great. It'll be online later. You can catch it. Yeah, cheers. Let's wait for the rest of the masses, the onslaught. Yeah, this is the right one. You're in the right one. Come on down. Yes, right one. Ah, come on. I just flew like 3,000 miles to come here. Come on. It's rubbish, as you say over here. All right, let's get going. First of all, let me just tell you, you're in the right session. This is the session about the wild and woolly area of application security training for developers. So this is an interesting, I guess for how many, 2 hours, 3 hours, 45 minutes? This is the whole premise behind this, and I'll talk about it in a second, was this whole world of application security training and whether or not it has an impact. So we'll get into this before we get going. That's me. I've been an application security person for about 10 years. I think I've been to every OWASP AppSec USA and several of the EU ones. I enjoy coming over here. Security professional ISSA guy as well. I'm also one of the 3 principals or owners, along with Dan Cornell of Denim Group. We're about a 100-person security firm in lovely San Antonio, Texas. I'm also a dad, and I'll just point out my wife is particularly excited that I'm over here for a week, not with her. She pointed that out on the way out. So. And by the way, promptly went to the beach for a week and said, the hell with you, I'm going to the beach with the family. So that was the response for me going to the UK without her, for the record. So lesson learned for the newly married guy. So I'm one of those guys that thinks about AppSec a lot, believe it or not. Like probably most of us. I mean, obsess about certain things around, right now it's OpenSAM and about training and we get really tough client questions. We're a professional services firm. We get a lot of tough client questions. And the ones that stick with us are the ones we can't answer. Or we know we answered and said, wow, I wish I could have answered that one better. Or I don't have any data, or here's what I think or feel, or here's what I perceive, but really not great answers. So I think about this stuff a lot, and probably about literally a week and a half ago, I was in South Texas and working on some writing about OpenSAM. True story, some thoughts around OpenSAM. And I was at my mother-in-law's ranch in South Texas. So she asked me, I'm working, writing, and she said, hey, I need your help. And I said, okay, sure, you're my mother-in-law. I have to obey whatever command you send my way. She said, we have this big drought, so I'd like you to go out with the ranch hands and go rattlesnake hunting. And kind of a surreal moment, because one moment I'm worried about like cross-site scripting errors and SQL injections and OpenSAM, and the next thing I'm looking for rattlesnakes. True story. And I went out, I said, okay, I got to get a picture of this. So, when I'm not thinking about AppSec, I think about this stuff. So literally, we go and gather a couple of ranch hands / guest workers, and went around and said, let's go do this. And for the record, how do you do snake hunting? Does anybody know how to do that? Probably not here, I imagine. You read about it or watch about it, right? So what you do is if you're really an idiot, you go out and get guns and do it. We're right below that, just partial idiots. So what we ended up doing is we said, let's get ready, and literally Saturday morning. So what do you need if you're going to do a snake hunt? I mean, literally, I forgot about this. I'm wearing an OWASP EU 2011 t-shirt. I had that down at the ranch. I was like, wow, that's where it went. I had the t-shirt. You had to have cool hats, obviously. Always important in that part of the country. Snake guards. You can't get those here in a shop, but you get those in South Texas. They're very functional. For the record, snakes bite right above the cowboy boot, right in the back of the calf. So those actually help. They kind of look a little weird. If they were black, they would have an S&M feel to them, but they're camouflage. Obviously common gardening tools, very important, because you can kind of hit the snake. And a machete. Now we're getting serious, but what you really need is you need a guy that actually has done this a bunch of times. So that guy is definitely a snake killer and has been very successful. And why do we do this down there? literally a week before, that was our swimming pool. Somebody heard a little, kind of sound like a zipper sound. Opened up the catchment for the swimming pool, and there's a baby rattlesnake floating around in there. So after we got that done, went back to AppSec stuff and back to OpenSAM. So just thought that it's kind of a weird, surreal Texas AppSec story for you. I mentioned Denim Group, based in about 100 folks based in Texas. We do work all over, mostly North America, some work over here. Much of what I'm going to talk about today is colored by the experiences we had with training. You know, we're a vendor, and we get asked questions about training, classroom training, e-learning, like, you know, what's the effect? How important is it? You know, if I buy this from you, what, you know, if I buy X amount of this, will I improve by 50%? And our response, or my response to all these questions involves some type of tap dancing routine, or kind of like, well, look over here, you know, or there really isn't a great answer, and that's the net of it. And at the same time, what really spurred me to start this particular effort was at the same time, Bruce Schneier and then a guy named Ira Winkler got in this nice little blog back and forth about the effect of security training or security awareness training. A little different, but the concept still held true, which was, you know, Bruce's argument was, hey, this is an utter waste of societal resources. You know, you're spending money on awareness training. It's filling the block. It is not making the users any smarter or any better or anything like that. And then Ira came back and said, oh, in fact, they are smarter, back and forth. Again, user awareness training. But I kept thinking, I think that's a problem. How about training developers how to develop code in a different way, in a more secure way? And I started thinking about it, and I started to characterize this, and it took us down this road. And I'll talk about the survey that we conducted, but I started to characterize this issue, and I realized a handful of things. First of all, it's a bigger deal for software developers, because, you know, how many people have done the ubiquitous corporate security awareness training? You know, it's 15 minutes, 20 minutes, maybe a link that you have to go past, or it is small, bite-sized training chunks. That is not the case for secure development training, for most that know. I mean, most of the vendors, including ourselves, have a 2-day intro to Java security program. That's 2 days, right? That's 2 days that you pull a bunch of people off the line. Or if it's the e-learning class, it happens to be the longest e-learning class in that library. It's not a 15-minute activity, so it's a bigger ask. It's a bigger ask of the dev folks, but a bigger ask of the business units, because the business units are the ones that are waiting for the stuff. So it's much more disruptive. And again, as we all know, we've heard this probably ad infinitum, they have the ability to say no. We call it the one-finger salute. Thank you very much. We have features and functionality that we've promised the business unit. It is the ultimate trump card. So first of all, it's not the equivalent at any rate of user awareness training, because it's a bigger deal and it takes more effort and more resources. And if you have 2,000 developers, imagine the disruption across the team. So that's one issue. But at the same time, we see organizations doing this over and over and over again. Why? Because guess what? We have folks like the payment council and, you know, industry, the payment card industry, excuse me, and mandating it. It's in there. 6.5.a, I think it is, says thou shalt train developers. That, by the way, for the record, drives most bought development. Most development that vendors deliver is driven off of that. I think 85 to 90%, for the record. And why do we know that? We ask that question. Why are you buying this? And they say, oh, because PCI makes me do that. Not because they have to or it's the right thing to do, but because PCI. So it's a little sad story there, but it's true. But that's in there. There's no effort in PCI to say thou shalt go back and validate or verify that there was an impact, that code actually got better, right? None of that. Kind of like the WAFs issue. You have to have a WAF. It doesn't have to be effective. But what I found out as I started to do literature review, and I actually had a graduate student, a computer science graduate student, assist me for about 6 months in this project. So let's go do an exhaustive lit review. And what I found out, number one, is there's very little literature. I mean, Bruce Schneier blog post is literature, I guess, but no scientific or no real academic research in this. And I found out there's very little research, period, in what I'd consider citable or academically cited on HR training. Pick one topic. You know, a compliance around, you know, equal opportunity stuff in the States. You know, have to treat people really nice. Every company has to do it. They check that block, that little box, but there are very few that have gone back to say, okay, let's see how well people have remembered this stuff, absent of a lawsuit. In a lawsuit, they get those questions in a legal setting. But for the most part, it doesn't get measured. So, and then I found out, workforce analytics in general, there's, so the whole training industry, not just security or AppSec training, the whole training industry, this is a real big criticism of not CIOs, but CEOs and CFOs. That like, hey, that's great, training, it's a feel-good thing, very little impact. So that's the starting point for this, this analysis. Very little literature, very little precedence. And if I look across the broader workforce and kind of HR world, there's very little there too. So very little cited. So on top of it, as we all know, the turnover for software developers is horrific. So in the States, there's actually a group called the Bureau for Labor Statistics. They capture these things, but typical turnover is roughly around 14 to 15% annual, per annum, for any company. It's worse within IT, it's 5 points more, but software development is typically 20 to 30. If you go to the frothier parts of software development, like Silicon Valley, it's closer to 30 to 40%. Some of that's anecdotal, but if you talk to most of the dev managers, it's about 30% in the places like Silicon Valley. My point here is, so not only do we not have much to cite, on top of it, if you trained your developers 2 years ago, it's not the same developers you have right now. Many of them have exited the organization, they've been promoted, they might have moved roles, many of them might have realized that they weren't great developers, they moved on. But that number is typically 20 to 30%. Do that out over 3 years, and you realize, wow, that is a total redo. And we see it as vendors, because we've been in public meetings like this or in conferences where we have a CIO or CISO client get up and say, we've done secure development training. And I'll look at Dan and say, I remember doing that brown bag in 2009 for those guys, for the, for the guys that we all know are no longer there. So in a management standpoint, they remember that and they'll say, oh, we did that. But the point here is, obviously, you've got to do it in a recurring way. So that exacerbates the problem. So let me talk about the research I did. And this was a major effort that started really last spring and then ended about a week before AppSec USA last year when I had to present. I mean, it was furious gathering data. First of all, it made me appreciate a little bit more, or a little bit of Gartner, IDC, Forrester, all those analyst groups that do surveys. Surveying is hard, and gathering data is really hard. And I'll talk about what some of the things we found out about that process that can apply to people within companies. And there are a lot of different things. Excuse me for that. There we go. So the first effort here, let me just talk about the overview of the study itself. It was focused on software developers, not security people, not general users, but software developers. And when I said broadly software developers, I mean software developers, QA folks, and architects. We didn't break out, BAs and all the different iterations and types of people, but we just said, here's 3 groups of people that we consider software developers. What we wanted to do was a handful of things, was to measure the awareness of the developers of key concepts in application security, and then whether or not training had an impact. Whether or not there was a before and after, which we found out was very, very hard to do. So we wanted 1,000 software developers. We ended up getting around 600, very US and North American centric, because that's where we're based. And as we found out, gathering these respondents was bloody difficult, let alone trying to do it in Europe or other places. So there's a definite bias for North America. You can read into it what you want. But we wanted to get cross sections of different verticals. And including financial, government, and I will just tell you right off the bat, we had a fairly high sampling of governments here for whatever reasons. We had a bunch of state government folks that responded, and also some very large energy companies. Being in Texas, overrepresented, that's where we're from, easier to gather. But we try to get a lot of companies also that were starting an AppSec training initiative. Those are the guys that really were incented to say, I want to know a before and after so I can report back to my boss. So a lot of those companies and organizations, there's a timing issue involved with this too, because we wanted to capture. And of those 600, we got about 100 that we were able to get a before and after. And I'll explain again how hard this was. So that was kind of an overview of the respondents' demographics. As far as company size, most of the people self-identified as software developers. Again, there's no validation of that. Titles mean different things to different organizations. If you notice in the right-hand slide, there's other. We got the people wrote down BAs, and we had everybody. We had folks that were in audit, folks that went into classes or took these classes. So this is an imperfect process. The other thing is, throughout this process, I had 2 political science professors that were coaching me, because this ultimately, the survey part of this was a political science kind of a statistical sample survey issue, less of a computer science and security issue. And they said, hey, this happens all the time. And so, as I'll talk about in a second, I'm doing a 2.0 version this summer, and we're going to try to refine so we get less others. That's one of the things that kind of surprised us. But the company size reflected who we were able to talk to. There's some big companies and medium-sized companies, slightly underrepresented in the financial area, and we'll talk about that too as well. Now, one of the interesting things is we had a lot of people that identified that they were in the software field for more than 7 years. That jumped out at me, first of all. We had 600 folks. So, again, it was very difficult to get people to respond, get all these responses back, and I said, wow, that just strikes me as unusual. We look at our development team, we look at most of the guys that we work with in Silicon Valley, and they're all 25, the millennials. Well, we went back and looked at the respondents. Again, we said had an oversampling of government and oil and gas. And guess where the 50-something programmers live? They live in public sector organizations and in oil and gas. How do I know that? Anecdotally, I did a lunch and learn for one of these large state agencies right before that, and I was the youngest person in the group at 48. Shocking. So, I probably, well, I'll just leave it at that. So I knew that anecdotally, and one thing I learned of this survey is, you have more than one anecdote that becomes data. And you can't ignore anecdotes as you're doing this. So that's one of the couple of things that these professors pointed out to me. So a bunch had no previous training, about 168, but you can see a lot of people did have some kind of training. Now, one thing we didn't capture that maybe I need to in this next go-round is, how long ago was that training? We're about 2 months into it, and I was like, yeah, that would have been a good one to ask, and kind of hard to ask. So again, this is, and I'll repeat this several times. There's literally nothing else out there along this line. So this will get better over time. But we don't know how long ago. We don't know what that class was. Was it a 15-minute intro? Was it a lunch and learn? Was it a 2-day class that a great vendor taught? Who knows? Okay, so methodology-wise, and I'm going to get to the data here shortly, but this is an important journey. 15 multiple choice questions. I originally talked around and said, well, let's use samples of code, and we can do a before and after, or we could have them identify vulnerabilities or fix things. What we realized is that was going to be exceptionally difficult. And number one, the many different platforms that people code in, different languages, it was just too difficult to do that. So what we wanted to do, and then also the grading, there's shades of gray, and did he do that kind of well? Did he answer that one kind of well? So what we ended up doing is we came up with 15 questions that we felt were representative of 2 different areas within application security. One was awareness. What is a cross-site scripting error? Number one. And number 2, how do you fix a cross-site scripting error? More the defensive and more the prescriptive stuff. Very different. One is, again, general awareness. Do you know what it is? And the other is, like, when push comes to shove, how do I fix it? We target software developers, as I mentioned. We did it online. We did 2 or 3 things. One is we had classroom training. We had several classroom training sessions. And actually, Dan was one of the guys that delivered them. Had a captive audience of 25 people. We did the old school, printing them out. And the real sobering fact that we learned is, like, not all of them filled the first session of 25. We got like 12 back. And I was like, what the hell? You were in there in the classroom with them for 2 days. And so right off the bat, we found out that, developers don't like to do training. No, well, we'll talk about that and how incentives matter. But that was a wake-up call early on. We also sent it out to these organizations via SurveyMonkey, and then we also did a Twitter and Facebook campaign for a while at the very end to get a broader sample. So we had 3 hypotheses going in. You have to have hypotheses as starting points. A couple of them bore out. A couple of them were very shocking. First of all, the number one that most software developers still don't have key concepts of AppSec under their belt. They still don't fully understand. That we hoped, and particularly as a vendor that does this, that there's some impact, some positive impact after training. We hope that there's not a negative correlation. That would be bad, or nothing. So we hope there's some positive one. And then the last one, given our work with financial services industries and banks, that those guys have a much further starting point. They're better. They're much more regulated. They get it. That one did not bear out in this particular survey, but we'll talk about why we think that is the case. So here's examples of the sample questions. As I mentioned, these are the awareness types. Are you aware? These are basic 101 stuff that I'm honestly, most of our sales force at Denim Group could probably get right if you've been through awareness. And here's an example of the prescriptive ones that came out. And again, how do you help protect against these things? So we're going to mix these up this next go around. And it was very interesting. There was a couple that people bombed, a couple of awareness ones that people bombed. So that may, so one thing you start to realize, maybe that's a bad question. Next go around, we'll throw that one out and use one. But in general, we learned some things. So let's talk about the key survey results. So this is what everybody's interested in. So right off the bat, we saw a couple things. And number one, that architects, as you might imagine, had a much higher awareness of concepts and prescriptive stuff, as did developers, but QA overall did poorly. This is an important one. This is a broad slide, but if you dig deeper into the data, and if you start to throw a couple things out, it gets even worse. This is important because in a lot of organizations, the AppSec function lives in QA, right? And if you're relying on the QA group to do AppSec, and that's where you also park your most junior developers, how many people do that? How many people have an intro? I mean, the entry point for development is to go work in QA for the first couple of years to understand automated testing. That's a lot of organizations. So they're learning how to build software functionality or to test it more accurately. They're probably not going to be able to get the AppSec stuff. So that's a key thing to look at. We're going to tease that one out the second one. So the second one, as I mentioned, they got the awareness ones pretty well, but didn't know how to operationalize that across that. The biggest one was the difference between the cross-site scripting error differences. That was a big one, and that jumped out at us. This was an interesting question. 100% could define input validation, but nearly 9% correctly defined proper session IDs, which is reassuring. So we had some that were counterintuitive in that regard. Okay, so here's the other big one. 25% was the number that we got out of this survey, before and after, before classes and after classes. We have the contact data for virtually 100 of those people that self-identified and were able to come in and say, yes, we'd like to retest. One of our things we're toying with is trying to see how many of those 1 to 100 we can go back and see a year later and see how much they remember. That might be more, that might be this whole presentation the next time. It's just what those guys did. But I'll tell you, it was very difficult to get them to, not everybody wanted to opt in and to identify. In order to get back in touch with them, we have to have some contact data, typically an email address. The vast majority of people didn't want to present that. So 100 out of 600 self-identified and did that. But so about a 25%, and that was like class, know nothing, take class, take a quiz. So that's right after. So retention is probably not going to get better. It might go. It depends. They might have put these practices to work. They might. Who knows? They might be the same. But that's one thing we want to go back and test. This one I wonder about. It said enterprises of more than 10,000 personnel have the lowest secure coding knowledge. I think that goes back to that state agency, state public sector workers, and oil and gas industry who are oil and gas guys are. Excuse me if they're in here. They're not financial services folks as far as security. So I think that might be skewed. That jumped out at us, but I don't know about that. The majority of the response had no prior secure coding training, but that might be surprising. Again, I don't know what to read into that. What we really need to do is go back and correlate those answers, the training to the people that passed and didn't pass. We weren't able to do that. Okay, and there was no correlation between the years of experience and knowledge of secure coding for effective training. Again, that is one that I think gets washed out over all those numbers, and one that we're going to look at more closely. Okay, the respondents that had more than 3 days of AppSec training in the past were able to answer more than half the questions correctly, which is okay, except for we typically say 70% is a passing grade. Most organizations say that. That's okay. And then 100% correctly identify where cross-site scripting executes. Oh, that's not good. That wasn't me. I'm still sitting. If I can go for 35 hours straight, the The AV system should be able to go. Well, let me talk through this while we're doing it. And I'm going to go through. What's that? Like, okay, yeah, wow. Okay, so I'm going to just go off tether here. Some of the stuff about the state agencies, the large organizations, and the older workers. Okay, we kind of knew that. We had some context. Here's one. All right. All right. One thing we learned, it wasn't at all in the questionnaire, and we are going to tease this out next time, is how radically different developers learn from the way that companies teach. And what I mean by that is, if you're a big company and you have to do an AppSec program, there's really two ways to do training. There's two or three. One is to do classroom training. You either do it yourself, do lunch and learns, get people together, or to do is distributed e-learning, CBT, do it in a less disruptive way across time. You can also do, webinars. There's all these different little kind of in-between ways. Those are typically what we call very formalized training, and they're easy to document. And if you're, for example, a QSA, you want to see that course outline. You want to see who consumed it. So that's a formal and kind of static way of doing training. And one thing we learned is developers hate that type of training. Why do they hate that type of training? There's two reasons. Number one, it takes them off of their deadlines, obviously. But one thing we realize is that training is supposed to be designed broadly for software developers. But as soon as you go in a big enough company, they have people that are doing PHP, that hit Ruby on Rails. Like if you make them take a .NET class, we've seen that before, has the exact opposite effect, and they just turn off. The other thing is, but more importantly, what we learned is that developers learn much more informally. The term that Gartner uses now is called social learning or social contextual learning. So what they're doing is they're learning from peers, they're learning from each other, they're learning from obviously RSS feeds, they're learning in smaller bits and bytes, but they're doing it more frequently. And if you look at the mobile languages as a great indicator of that, most software developers started out having formalized education, probably have a bachelor's of science in computer science. But after that, that's the last time they sat in major classroom environments, right? I mean, for the most part, unless you went off and got a PhD or master's. Nobody went off and took 4 weeks off to go to Android camp or to learn iOS. They did it on the fly, right? They did it on the fly. So that's contextualized learning. That's social learning. They did it in smaller, but they learned it. These modern the frameworks that are out there. We went off and went to Ruby on Rails formalized classroom training. There's very little of that happens. So that's the thing. How do you then tailor if you're building a program? How do you do that? You have to use these platforms and these programs that your auditors want or your management wants because they spent money on it. They don't want you to do social learning, to conceptual learning, because you can't measure. It's very amorphous. But at the same time, that's how your developers learn. So you got to take bits and parts of each of that. The other thing that I would say is incentives absolutely matter. What I mean by that is, I told the story about the classroom training where we were sobering, in a sobering way, found out that nobody finished the forms. We had, out of that 600, about 150 that were not completely filled out. I call it, survey fatigue, whatever you want to call it, but so a lot of people didn't finish it. Towards the end of the survey, we ended up throwing out Amazon gift cards. And remarkably enough, every single one from that point on was filled out and completely. So if you're rolling out a program internally and you think people are going to do this stuff because it's the right thing to do or they want to do it, that's probably naive. Spend some money, get some gift cards, and suddenly they pay attention. And if you think that you're above that, then don't go outside and take any of the little vendor tchotchkes. Because I've seen many of the mighty security guys go and trick or treat like everybody else and grab the little thing. So the reality of it is we're human beings. We have kids. Some of us do, and But so incentives matter, right? And that was a sobering thing that we noticed. I talked about this a bit. Again, the rise of social learning systems. That's kind of a buzzword term, but that is one that's out there that, and there's, you know, the term learning management system is very much an e-learning thing, but they're all having social network components to them. So if somebody sees a cool article, they can share it across the dev teams and all that. Some of that obviously is done through existing platforms, but corporations are trying to formalize that so that they can measure it a little bit more. Again, on one end, they've got to be able to tell their auditors or shareholders, yeah, we're doing training. On the other end, you know, they don't want to make it drudgery either. So here's the other thing. Refresher training is obviously still needed. We're going to try to hit the follow-up survey and hit the 100, but obviously that's like any other classroom thing. If you don't apply it, or if you're not familiar with it afterwards, if you're one and done, you'll forget everything. The most successful organizations we've seen, the people that pay attention in class, are the ones where it's built into their performance reports, the developers, you know, in some type of fashion. I think the famous one or infamous one was Microsoft checking in bad code, vulnerable code. If you checked in vulnerable code 3 times in a row, you got fired. I don't know how true that was, but it does matter. We've seen organizations that have put that in performance plans. People pay attention. If you let them know that's in their performance plan before they do training, then it also becomes more important. We've seen a couple of innovative companies where they just literally will take a little video snippet from their CFO that says, hey, I know you're here for a day, this is important, here's why it's important, pay attention. You know, we take our customers' data real seriously. You saw what happened at Target, you saw what happened over here, you know. Just a 15-second snippet is better than nothing. And then the other thing that I would encourage everybody here to do is be able to at least try to measure some type of numbers, because managers, if you go to MBA school, I went to business school, if you talk to CFOs, they live in the world of numbers, and they view the rest of the world as being lazy for not doing that. So like, why do I get to live in the world of numbers and you just get to prance around and talk about security stuff? So if you have some kind of measurement or even an attempt at measurement saying, hey, this is what we're trying to do, that goes a long way, because the rest of the world, business units, projects for profitability, they all are measured against that standard. Mention the incentives, obviously Amazon cards or anything like that. So again, key concepts here. Unfortunately, software developers still don't know the key concepts, unfortunately. You know, they really didn't do well on the prescriptive stuff. Most of them failed. The next time we do this, we're going to try to differentiate the people that have taken classes from the people that haven't, do a better job of that. You know, but it does increase about 25% is what we saw. That was that does speak to the, you know, some impact of training. We'll see how long-term it is. And I think, again, the big one that jumped out at us was the QA one. We did not anticipate that. It wasn't one of our hypotheses, but they really did not do particularly well. And we're going to really spend a lot of time trying to do that. The other one is business analysts, right? We didn't do PMs, but BAs are the ones that translate business unit requirements to software, at least in theory. Like, if they're not baking in any requirement for security, then the developers are going to ignore it too. So we may break out a category for BAs as well. So I guess this died again, so that's a good time to wrap up. And wow, it's not my AV day. So with that, I'll open up for questions. Or no questions, either way. Yeah, go ahead.
For better metrics, could you get the results after projects? So before the project, now is finding the security test, and after that, is that not a better way of metrics?
Yeah, that is I mean, ultimately, the best way is to look at code, before and after, or the results per line of, you know, vulnerabilities per line of code. The problem is gathering that data. If I learned anything out of this, is the gathering process for this is very difficult and manual. And that might lend itself to doing the internal idea that we talked about to prove to your manager. That's easier done on a much smaller scale, but you can't do that and then do a survey because it's so different from teams to teams to teams. So that's where, if you're looking for a way to impress your manager, say, here's what we did it before and after, that probably will carry more weight internally than externally. It's my 2 cents. Yes, ma'am.
Any plans to broaden the scope beyond the US
Doing this again in July, and July is remarkably close to today. So get back next Tuesday. If you're interested in participating, I'd love to have I have folks over here do that. I mean, it's what it is like I don't care about the clients. It's the anonymized data that I really want. And I'd love to, if there's other companies or other individuals or vendors, honestly, that want to play, I'd love to play, because it was a huge effort to get that 600 respondents. And like I said, 150 didn't even finish, and we were worried about that. Yes, ma'am?
So you struggle with getting like the link out?
No, data collection, responses. You can get the link out, and you can do all these different things. It's getting valid responses, or in the case of the 150, people finishing it. So we had 450 that were finished. And this is after going to multiple companies, going to partners, going to social media, Twitter, and we did as many avenues as a company can. Now, by comparison, to give you an idea, we know of at least one other vendor in our space, and everyone's space here, that went to go get some benchmarking data around OpenSAM, and they paid IDC 60 grand to do a dumbed down version of what we did here. 60 grand for 2 months to go and do carpet bombing to get all this data. And so it's not a trivial effort to get the responses in. To craft it, and the science behind that I thought was really the hard nut to crack. It wasn't. It was the collection part. So, yes, sir.
So you touched on the simple types of training. Mm-hmm. You also measure the results between, for instance, e-learning and classroom training?
We did not. That's a great idea for the next time around. The sample between, I think we probably had about 60 in e-learning, 60 in classroom training, and about 40 in e-learning. So I don't think the sample size was large, but that's a great point. My suspicion, hopefully, is that the classroom training would have a larger impact than e-learning, but I think the sample size was too small, again. But that's a great one. I'll consider that going forward. I think that the BAs, pulling out the BAs to see if those guys, because out of that 150 that said other as far as jobs, I think a good 60 were BAs, business analysts. Yes, sir.
Recently, we've been chatting quite a lot about the COVID side of things and the knowledge of your data. How much of this needs to be bred out from university now rather than
All of it.
new graduates?
All of it. Let me address that one. First of all, I think there's actually more hope over here. The way that you promulgate security standards is a little bit more top-down. In this instance, it actually works a lot better. In the States, it's every man for himself, every state for himself, what we see is it's a very much state-to-state, university-to-university initiative. And if most of the largest universities have a security development class, it's mostly one lecture is about defensive coding. The rest are about encryption, because that's what the professor understands. That is the brutal reality. It might be different here. I understand it was a trusted software initiative. Trustworthy software initiative in the UK is an effort to push some of those standards down. Because you have a much more centralized higher education system, more standardized from the central government down, you may have a better chance of pushing that than we do. Ours is all state government, and again, Texas is different from the other 49, and that's where our system fails. Yes, ma'am.
I just want to say it's not that centralized. There's one thing about the UK academics you can say is that they're very fierce about their independence. So defining it was step one. Getting it in is step 25.
Well, that's what I thought on the other side of the Atlantic. At least that's what I was telling. Well, then I probably, that was my perception, assumption. I will say in the States, it's terrible. Like if you're a tenured professor over there, unless you do, I mean, and these guys are comfortable teaching the same topics that they've taught forever. So you talk OWASP and defensive coding, and that I think Carnegie Mellon, I think Purdue, and 2 or 3 other schools, they have what we would consider a secure development class. The rest are some secure system class, and it's mostly encryption and Orange Book or whatever stuff that it's science fiction-like and not applicable. Yes, sir.
This is sort of aimed at teaching developers how to code defensively and write decent stuff. Have you any plans to do something similar with test, to actually teach them to think outside the box and basically do effectively negative testing of security rather than positive testing of requirements?
I was being ambitious with this, but not that ambitious. That is a age-old problem, and I think it's close to that QA issue that we talked about. If it sits in QA and your most junior developers are testing for AppSec cases, then you're in a tough spot. And our experience is that if you have to switch a bit and think differently, and most QA people don't. They still don't, and it's discouraging. I mean, we've been in this business since 2004-ish, and there's days that we just go, oh my God, we've had no effect. You know, we've been out there flying across the Atlantic, proselytizing, doing these things, and there's days when the point is these QA people that are here in 2014 are different from the people that are in that same role in the same company 2011. They just cycle through. So if you're not doing that constant training or velocity of training, then you're there. You're in the same position you were. So I don't know. I mean, it's the age-old issue. You know, absent of again Target-like breach. That's an example we have over. You know, where the CEO gets fired. It's a $500 million hickey that hits the pocketbook of the shareholders. You know, how do you get people to do the right things absent of a near-death experience or a death experience in the case of a breach? And that's just a real hard thing to do because it's so easy. I mean, there's QA magazines. There's a whole like a subgenre of QA. Believe it or not, I saw one the other day, a quality test magazine. They don't talk about this stuff. And I think Dan got selected to speak at Java 1 this year. There's a couple of security tracks there, but I mean, most of what they discuss there is absent of this. It's like a different world. So it's changing a little bit. All right, well, I'll be around if you have any questions. Thanks for bearing through the AV problems. And again, if you're interested in this, grab me because we're starting this again, and it was bloody difficult. I'll just add that. Cheers. Thank you.
Okay, so can you hear me okay? Yeah.
Alright, I'll give people 2 more minutes. I'll give people 2 or 3 more minutes because the
Okay, yeah,
session's just
perfect. Okay, so thank you all for coming. I know this is a bad time because it's late in the afternoon and some of you have to take trains, planes, and so on. This is automatic detection of inadequate authorization checks in web applications. I know it's a kind of academic title, but this is Cambridge, so what the hell. My name is Álvaro Muñoz. I work as a software security researcher for HP Fortify. I've been doing security-related stuff for the last 10 years as a pen tester and application security consultant. If you're wondering where my accent is from, I'm from Madrid, Spain, so please don't mention the World Cup at all. And if you want to contact me, well, this is my HP email and my Twitter handle. I would like to virtually introduce you Divya. Divya was the original researcher for this project, but she couldn't make it here to Cambridge, although she's actually working based on London, UK. She worked on his postdoctoral research in working similar techniques that the ones that we are going to present today, but for operating systems, services, daemons. So this is just like an evolution for web applications. Okay, so the idea for this talk is to talk about, first of all, what's the distinction between design flaws and code level bugs. Why should we care about finding design flaws? Are they important? Are they popular? Are they present in the real world applications? What are the current detection techniques? So how can we find them today? And we're going to propose like a solution, a new technique, a novel technique to find them using purely static analysis approaches, right? So it's something that has been done before, and well, this is just not even a beta, it's a POC. It's working, and we are proving it in real-world application with very good results. So it's something that we eventually will end up in the product. So first of all, the distinction between code-level bugs and design flaw, is it clear for all of you? Well, just to make sure that we are all in the same page. Code-level bugs are bugs that we can I change the mic? I think this one is maybe the water. Can you hear me if I speak like this? Okay, fine. Okay, thank you. So just to make sure that we are all in the same page, code level bugs are bugs that we can find in 3, 4, 20 lines of code. So we have a source that is clear state in the source code, and a sink, and we have a data flow or a structural pattern that we can find purely in the code. Design flaws, we require to check the specification, the design of the application to make sure that it's a design flaw or is something that is supposed to behave like that, right? So let me put some examples. For example, code bugs is a SQL injection, cross-site scripting. You have a source sink, and you can see how the data propagates from the source to the sink, and you don't have to check the requirements or the specification for this particular application to make sense out of the SQL injection and find that this is a bug, right? However, with design flows, imagine, for example, an application where you have an application to manage your employees' expenses. So if an employee can approve his, or actually if a manager should be able to approve his employees' expenses, but not his own expenses, right? It's something that is common sense. However, if the application is not checking for this control, then it's going to be a design flaw. If that is specified in the design, like for example, managers are not supposed to approve their own expenses and things like that. So this is a design flaw because even if you are actually in the code, you can see that there's a missing authorization check. You have to go to the specification and make sure that there is a requirement saying that you should be placing an authorization check there. So this is somehow the mandatory funny picture, but it has a goal. Do you think that this is a picture level bug or a design flaw? How many of you think this is a bug? Really? How many of you think that this is a flaw, a design flaw? And how many of you think that you don't have enough evidences with these pictures to actually know if this is a design flaw or a code level bug? Okay, I'm more with you, but we are open to other suggestions. So maybe this street is just right in front of the Tate Modern Museum, and this way of planting the trees is something that is this way by design, right? So we cannot tell that this is a design flaw without checking the specification. So that was kind of the purpose of this slide. So let's take it to the code that we are more familiar with. This is a typical web application where we have different roles. So for example, we have an administrator role that have access to an admin panel where he can create or delete accounts. Also, we have a user view where the user, as a regular user, cannot access these features because are supposed to be only accessed by administrators or some special privileged accounts. Now, if this is the code in the backend server controller, so looking at the code, can you spot any problem in this Spring code? I don't know if you can actually. So there are two functions here, the create account and the delete account. And one of them is mediated with this pre-authorized annotation, right? So it's checking that the ones that you are going to call this function here, the create account, it's going to check that you have the right permission, the right role in order to execute and run this function. However, the delete account is actually missing this check. So anyone from the previous user interface can actually delete any of the accounts without being an administrator and just finding out which is the right URL and just executing and accessing this method. Okay, so for code level bugs, it's something that is supposed to be easy to find with static analyzers, right? Because static analysis are supposed to take the code and have complete visibility in the source code. So if the code is completely contained within the source code, it should be easy to find there, right? So maybe you have to fine-tune this static analyzer for the particular technology stack that you're using. So you have to have a good coverage for the libraries, frameworks, language that you are using. But once that you get to that level, you are supposed to find, if not all, most of the code level bugs using a static analysis tool. However, for design flow, it's not that easy because you have to check the documentation. You have to check the architecture, the requirements, the specifications, and then you have to check the code, check that the delete account method is missing an annotation, and then go back to the specification of the application and try to find out if it was supposed to have an authorization check there or not. So in order for a static analysis tools to be able to find design flaws, they should be able to take this pile of documents there, put them into some format that the tool can understand, and then run the static analysis tool to find missing authorization checks. But this is not practical because there is no way, actually there is no standard format to do that. And even if we all find a standard format to do that between different vendors, open source tools, and so on, we are going to translate like plain English requirements, like for example, this manager should be able to only approve his employees' expenses, but not their own expenses. We have to translate that into this set of functions, like the approve, expense, or whatever you call it, are supposed to be executed only with role manager. So that's not an easy translation and requires a lot of, of involvement. And if we want to make it like scalable, then, I mean, if you're going to scan one application, there is no problem, you can do that. But if you're going to scan like hundreds or thousands of applications in your organization, then this is not a practical approach. OpenSUM have a very good distinction between code level bugs, design flaws, and they have these verification activities right here, design review, code review, and security testing. Actually, design review is supposed to find design flaws, right? Just by reviewing the design, the specification, the architecture, finding flaws there. Code review is supposed to find code level bugs. And security testing is like a second layer of protection to make sure that you did a good design review and a good code review. So if you did a good review of these two previous steps, you should not be should not be finding many issues during the security testing activities. Now, if you go to the code review activity in OpenSUM, you will see that the second level of maturity here says that you have to do some code review, right? Because again, if you have one application, then you can do it manually. If you have hundreds or thousands, you want to automate that in order to do it more scalable. Also, if you want to be even more mature in the OpenSUM scale, then you have to fine-tune the application, the analyzers, in order to understand the technology stack that you're using. However, if you go to design review, there's nothing like that. There is some services here, some gates there in order to create meetings to review the documents, the specifications, and the architecture of the application, but there is no way to do it in an automatic fashion, right? And this is a problem because we are seeing that there are many design flaws that could be identified with static analysis, and we cannot do that because there is not technology support right now for that. So this is OWASP Top 10. If we focus on the last year version, there are two of them that are design flaws. And with design flaws, there are many categories, right? We have like missing authorization checks. We have, for example, broken logic in the application. Like, for example, if you change the order when you are buying something, then you may be able to buy something for free without paying for that, and so on. But if you focus in the top 10, it seems like the most prevalent or more popular ones are the ones related with missing authorization checks. So A4 is insecure direct object reference, and is basically if you are exposing an object or a resource in the server, and you're actually not protecting it with an authorization check, so the URL to access this resource can be predicted. And for example, you have some confidential data or resources that can be accessed just by predicting the URL. So one example for this is the Bloomberg when they grab the NetApp earnings just by accessing a different URL with a different date and so on. The other one is A7, right? This is new this year, actually last year, and it's a missing function level access control. So now we are not talking about resources in a web server. We are talking about the exact example that I showed you with the admin panel, creating an account, deleting an account, when you have some controls to show some controls or not, depending on the role that you have, but you are not replicating these controls in the backend. So you are missing the authorization checks at the function level, and then you're opening the doors for attackers to predict the URL and access those resources. So one example is the Citibank hacking like some years ago in 2011, when they were able to change the user ID in the URL, and just by changing the user ID to another ID, they were able to access sensitive data from these users. Because actually they were missing like a function level access control there. Okay, so what are the current approaches to find this kind of missing authorization checks? As far as I know, the only approach right now is dynamic, and it's basically scanning a web application with 2 or more different roles, comparing the results. So you have like an attack surface for administrator, an attack surface that is different for a regular user. Then you compare them, and the extra attack surface that is available for the administrator, you can scan it using a regular user, for example. Then if you find new pages, or these pages that are supposed to be accessible only for administrators are accessible for regular users, then you can raise a flag and say, this is wrong or should be different, right? But one of the limitations is that it's dynamic, so you have to set up everything. You have to ask permission to set up the application in the pre-production environment, QA. You have to ask permission to scan it. You have to prepare everything, so it takes more time and scales worse than static analysis. And also, it can only detect missing authorization checks. So it can detect that you can access something, but it cannot detect that there may be different ways to access the same resource with different authorization checks levels, right? So what we are trying to find is a solution that works for web applications that is static, purely static, so we can scale it and run it on thousands of applications very quickly, and also that finds both missing authorization checks, but also inconsistent checks. So things like this function can be accessed through this path here, with asking, for example, for an administrator role, and through this other path can be accessed without being an administrator. Just by being authenticated into the application, you can execute the exact same code. And the most important thing here is this requirement is not require any training or any preparation for the tool. Because if you have to take the documents, the pile of documents that I showed you for, translate them from English into a XML or any format, and then feed the static analyzer with that, there's no, I mean, it's not going to work. It's going to work with that, one application maybe, but it's not going to work, and it's not going to scale. So this is our approach. It's a 3-step approach. The first thing that we are going to do is create a specification of the application. So what is currently being access checked? So what functions are being protected? Then we are going to identify all the operations within those functions that are being protected. And in the second step, we are going to find those functions that are not protected. We are going to find the operations that are contained within those functions that are not protected. And then we are going to cross-check them, find the anomalies, and present the developers with some suggestions, some remediation advices on how, where is the missing authorization check and what check should be placed to protect that part of the code. So the first part is creating the specification. And to create the specification, you have to identify all the methods that are protected with access checks. And for example, we started only with Java, and actually we are only working with Spring Security and Apache Zero right now. And these are the ways that we found that these frameworks, Apache Zero and Spring Security, are protecting the code, right? So they can do it just by using URL access checks, aspect-oriented programming with point cuts, annotations throughout the code, or programmatic checks like if-else checks, like I'm protecting this block of the if-else statement and not protecting the other one. We also have to consider not just these functions that are being protected with, for example, an annotation, but if this function calls a different function, the second function inherits the same levels of protection that the first one. So we have to keep track of the way of calling these functions and protecting all the possible paths. So some examples of how the applications are actually being protected right now with Spring Security. This is a configuration file from Spring Security. This is the intercept URL tag. And basically what you're seeing here is anything in this map to the admin URL is going to require the hash role administrator, right? This is a different URL pattern index, and it's going to require the user to be authenticated with any role, user, administrator. This is just one example. Aspect-oriented programming, point-cut-based, so you can say things like, when the code is going to call any function within the com service namespace, it's going to check that the user is role user, right, for example. So it's going to intercept the calls to these functions, and it's going to place some access checks for those functions. Another way to do the similar thing is by protecting or placing these same checks at the method interceptor or at the bin level. So at the bin level is the most obvious one. So you have this bin, for example, the demo account service implementation, and you want to protect the create account and require be user, and to delete an account, you require the user to be an administrator. The other way of protecting is just placing all of the access check together in the same list. So it's a centralized point of placing all the checks. As you can see, there are many ways of protecting the functions, placing the functions using aspect-oriented programming, URLs, annotation. So we have to account for all of them and identify those functions that are being protected. So this is another way of protecting using annotations. The first example is Apache Shiro. So in the first example, there are two annotations protecting and asking or requiring two different sets of permissions or checks to access the post and find accounts methods. The second example is Spring Security, and it's basically the same idea. You have some methods that are being protected by annotation. So any operation that is contained within that function is going to be protected and is going to require the user to have those access checks. A different place or layer where we can place authorization checks is in the view layer. So we can do things like, I'm going to show these controls if the users are authenticated, or I'm going to show this greeting, for example, if the user is an administrator, or I'm going to show this delete and create account controls, like I saw before in the example, if the user is an administrator. So we are not caring about this access check at this point. They are important because if we find that there is an access check in the view and in the corresponding part of the controller is not being checked, then we can find that there is something wrong. Because if you're not showing something, normally it's because it shouldn't be accessed by that role, right? But we are now focusing right now in the backend, in the controllers, in the services, and so on. Okay, so the last way of placing access checks is at the block level. Instead of protecting a whole function, we are protecting just a block in an if-else statement. Like, for example, this one is protected by the hash role administrator. This one is not protected, right? So all the operations within the protect block have to be considered for the analysis and to be placed in the specification. So the first step within the first step, that is creating the specification, is to identify all the functions and all the blocks that are being protected. The second step in the first step, that is the create specification, is to identify all the operations within those functions. And for an operation, we refer to a verb and a direct object, right? So for us, an operation right now is just a function call. We can also consider in the future variable assignments or other type of operations, but we are now only caring about function calls. And when you call a function, you are invoking a function that is the verb, what is going to be done, and the variable can be, for example, the instance object, or one or several of the arguments is the direct object. It's the object that you're going to action upon. Also, we have to discard some of generic methods that are going to be all over the application, like login methods, methods that are being called from many different call sites. So they are going to be heuristically detected and basically discarded because we cannot infer missing authorization check by a method that is being called from anywhere, right? Okay, so this is one example, a simple example where we have two different methods. The first one is getCocktail, and it's protected by the pre-authorized check, and is actually accessing the get method in the cocktails variable that is actually a list, right? A Java list. Now, we have another method here that is the delete cocktail. It's accessing the same exact operation, so it's the same variable being accessed. It's actually the class member, and it's accessing the same method on the same variable. However, this one is not protected. So we can infer from here that maybe the developer forgot to place an authorization check in the delete cocktail because of the set of operations that are being protected in a different operation. Now, a more complex or more realistic example, we have, for example, the same idea of a getCocktail method here in the middle. However, the authorization check is not placed right in the implementation method, but in the interface. So this interface declaration, and actually here in the method implementation, is inheriting the authorization check from here. But also, if you see, there is a mapping here to the admin URL. So this method is invoked and is mapped to the admin getDrink URL. So there is another authorization check that is mapped with the admin URL pattern, right? So we have to consider all these authorization checks. In this case, it's requiring the is authenticated. So this method is going to be protected by both the pre-authorized annotation and the is authenticated check. And all the operations within this method, in this case, there is only one, the lookup cocktail, are going to be protect and inherit all the set of checks, right? So in this case, you can see here that the implementation of the lookup cocktail contains a call to cocktails.get. So in this case, there is one operation that is cocktails.get, where the verb is get and the direct object is the this cocktail variable, and it's being protected by two different sets of annotations, of checks. Does it make sense? Yes? A little bit? Okay. So second step, we have now a specification, right? We have a list of all the methods that are being protected and a list of all the operations that are contained within those methods that are protected. So now we are going to find anomalies. So given a specific class where we have found methods that are protected, we are going to look for other methods that are not protected, and we are going to look for the operations within that method. So we are only going to focus on the same class or methods invoked with a call stack that access that class, because normally developers place the access checks at some layers. So for example, the service layer or the data access layer. So we don't want to just check for all the classes and look for missing authorization checks in helper classes, utility classes, and so on. So we are going to look for the same set of operations, right? So for example, in the non-protected methods, we are going to look for operations that are going to be identified or profiled by a function and one or more variables that in this case can be the instance object, arguments, and so on. Also, we can fine-tune the operations. So for example, imagine that we are accessing some methods in an ORM framework. So we have the typical CRUD actions like read, update, delete, create. So normally, they don't require the same level of access, right? So the read is normally less privileged than the create, delete, or update ones. So if we can map some of the operations to CRUD actions, we can actually provide more accurate results to the developers. So we are classifying all the operations or all the anomalies that we find. So we cross-check those operations that we found in the non-protected method with the operation that we found in the protected ones, and we cross-check them and create a list of anomalies. So if they are acting on the same variable and the same method, we call them this internal name, like same var, same method. It's just like a label to identify this class of operation. So each of these 4 levels are going to have a different severity, because if we find that something is an operation on the same variable and on the same method, this is going to be critical because it's going to probably is missing the authorization check. However, if it's the same type of the variable, same type and different method, maybe it's, and we will show you some of real-world examples with verified missing authorization check where the actual pattern of the operation is same type, different method. So they can be true positives, but the probabilities for them to be true positives are lower than a same var, same method, right? So this is the example that we saw before. In this case, getCocktail is the same variable, it's this cocktail that belongs to the class, it's a class member, and then the get function. So as the delete cocktail and the get cocktail are invoking the same operation, we can infer that there is a missing authorization check. Now, we are not only looking for missing authorization checks, but also inconsistencies, right? So if, for example, we find that this method can be invoked from the get cocktail and the delete cocktail, and one of them, one path, requires the user to be administrator, and the other one just requires the user to be authenticated, we can present the developer with, this one is missing the administrator check, or this one may be missing the is authenticated check because it's inconsistent by itself, right? Okay, so suggest remediation. This is the most important part because we have to present the results in a way that is easy for the developers to understand and that provide them with enough evidences to support our findings. So basically what we are doing is presenting what are the functions or the operations that we identified as anomalies, and we are providing evidences from other places in the source code where we found that those operations were protected by some authorization checks. Sometimes we have to provide the developers with a call stack. So for example, we found that this operation is similar to this one that is protected, but this one that is protected is not directly protected. It's invoked, and this is a call stack of 4, 5, 6 method calls, and in the top of the call stack, there is an annotation protecting the enclosing method. So we have to provide them with all the evidences and all the information they need to quickly identify if this is a true positive or not. Okay, so this is a summary of the steps, the 3 steps for the example that we have been using. So the first step is create a specification, profiling the application, identifying all the functions that are being protected by AppSec, identifying all the operations within those functions. Then in the second step, we are going to identify all the functions that are not being protected, identify all the operations within those functions, cross-check them, and provide the users with a list of findings, right? Okay, so now some real-world examples in the wild. So MIFOS or MIFOS, well, we run this POC in a bunch of open source projects in GitHub. This is the one the biggest one. I will show you also the smallest one. This one is 300,000 lines of Java code and 100,000 lines of XML. And it's a pretty big application, and it uses both Spring Security annotations, but also some custom checks. We identified 77 anomalies in the application, and some of them are false positives because we are not checking for custom checks right now. And for custom check, I mean they created this has role method or has privilege or has permission, and they have their own library that is not Spring Security, it's not Apache Shiro. So we still have to provide the tool with a way to take this information. So these are the packages that we use in our technology stack, in our library to protect or to check for authorization checks, and just feed the tool so they are considered in the same way that, for example, we are doing with Apache Shiro, has role methods, and so on. So these are some of the examples. For example, this one is a same bar, same method, so the most critical level, right? So there is this method here called transfer client to branch that is enclosed by, or belongs to the class client service facade web tire. And as you can see here, the suspicious operation is the transfer client to, that it acts or operates in this customer service. So we found that there is a different method called transfer client to group, so instead of to branch, to group, that calls the exact same operation on the exact same variable with the exact same function, and the other one is actually protected by requiring these 2 methods right here. So all these examples that I'm showing now have been disclosed to the open source projects. They have been verified, and actually they have acknowledged that these were actually missing authorization checks. So if you go to the code, I know that the font is a little bit small, but there is this transfer client to here in the transfer client to group. The same operation is right here, this customer service transfer client to in the transfer client to branch. And actually there is no access check here, but if you go to the interface, because this method overriding the interface, then you can see that the transfer client to branch is not protected, but the transfer client to group is protected, is mediated. So we can infer that we can present this finding to the developers. And as I said before, it's 77 anomalies out of 500,000 lines of code. So it's not like, yep.
Sorry, if the transfer client to branch was
Yeah, because we first create a set in the specification. This method here, for example, client transfer to branch, sorry, will be identified to be protected with two different annotations. And one annotation and one access check, and then it will know that it's protected by two, well, actually it will find an inconsistency, right? So it will know that this one is protected by the annotation, and this one is protected by the URL. And it will present like this is not consistent, like the example that I showed you before. So another example is in this create question group. It belongs to the question service facade implementation, and it calls, or it contains this operation here, the define question group. And it's acting upon this questionary service, right? So we found an evidence that actually is called create active question group instead of create question group that contain the same variable, same method operation. So we can infer that since one of them is mediated, the other one should be mediated. Actually, if you go to the source code, you can see that this is a copy-paste of the same method. So there is no reason if one is protected to not protect the other one. So we tell that to the developers, and they agree that they forgot this is the interface. As you can see here, one of them is mediated, create active question group, and the other one is not. So they acknowledge that this is a missing authorization check. Third case is same type, same method. So now we are not acting on the same variable, but on a variable of the same type. So in this case is a constructor, I think. So there is a method called getServerInformation that is calling the constructor of the system.info class. There is an evidence saying that there is another method called system.information, getSystemInformation instead of getServerInformation, and it's also calling the constructor of system.info. If you go to the methods, you can see that both of them call the constructor here and here, but if you go to the interface, one of them is mediated and the other one is not. And actually, I don't know if you realized, but normally the ones that are not mediated are the last one in the interface. So like, it seems like the developers just wrote the implementation, copy the signature of the function into the interface, just copy paste, and they didn't understand the annotation, so they just leave it like that. This is just my idea. So this is another application called PJ Gallery. It's a very small application, just like almost 2,000 lines of Java code, and we found 8 anomalies. One of them that we reported to the developers and was acknowledged was this one. So actually, this is same variable, different method. So it's actually calling on the same exact instance of the variable, but completely different method. In this case, the get breadcrumb by ID is calling this operation here, get breadcrumb by ID on this album mapper. And we found not one, but 2 evidences of operations on this album mapper that are being protected by this set of operations, of annotations here. So even if get root and get by parent has nothing to do with get breadcrumb by ID, we report it as lower severity finding, saying that it may be that you're missing something here. And actually, they acknowledge that this is a true positive, so they were actually missing the annotation. So you can see the methods here, get by parent is protect. All the methods in this class are protect except by the last one. Again, the last one, so this is just my suspicious. So that's pretty much it. Next step, we want to work on just working on custom authorization checks because many frameworks implement their own stack or their own libraries for authorization checks. Another area where we can improve is reducing the false positives, so things like mapping the operations to CRUD actions, like I explained before, or increasing the granularity of the operations. Also extending to other frameworks, other languages like .NET, or other frameworks like, I don't know. By the way, I don't know if you know more Java authorization frameworks apart from Spring Security, Apache Zero. Okay. So this is pretty much it for me. If you have any questions. We are only supporting Spring Security, Apache Zero, and we are going to start supporting custom authorization checks. So maybe with custom authorization check, we support, or we open the set of programming styles, as you said.
My problem with this is that usually you want to audit like bad programs, like badly written programs usually mean like bad security. And those are the ones you want to audit. But with this one, you cannot audit like badly written programs.
You have to consider that this is something that hasn't been done before, you know, using static analysis to find this type of design flaws, because finding design flaws and, you know, trying to figure out what the developer was trying to do is very difficult, right? So, and this is just like the first steps into that direction. And I think this is the right way. I mean, we know that it's limited to this set of annotations in Spring Security, Apache Zero, these ways of defining access check, but I cannot imagine more ways to define access check. So aspect-oriented programming, configuration files, if-else statements, annotations, what else? So it's going to be among these lines. So,
Have you worked as a developer before?
sorry?
Have you worked as a developer before?
Not work, but I have developed many applications.
There are tons of really like code that does not look like that at all.
So
Not
I would love to not really to get more ideas on what kind of operations we should be checking for, what kind of access checks we should be checking for based on real world experience. So I would really appreciate if you can share that. Right now it's not an open source project, so it's just a POC, so we will see. I will. I don't know. To be honest, this is right now an HP project, so at some point it will be released, but I cannot talk about that. Sorry. Yeah.
I have commented that so there's a very similar tool developed by the University of Göttingen, Konrad Rietz there. I think it's called Chucky, but I'm not sure if the name is correct. And they also do very similar stuff. So they use machine learning to learn the different checks. So basically they learn there is a certain method, and before this method there's always an if, and there is if statement. There's then one other method, and this and not the same check. So they employ similar techniques.
So we haven't considered like machine learning for this approach, but I don't see any reason why not extending and adding capabilities of machine learning to cluster some operations and improve the accuracy. So as I said, this is a first steps, proof of concept, and we are trying to improve it and make it really useful for developers. Anyone else? No? So thank you all for coming and staying this late, and thank you. What do you think? About the idea, not the
I got
presentation.
about 15 minutes through and then it was beyond me, but that's a good sign, right?
Okay.
No, it's a conception. It's very good idea.
We're getting good results in real world code. So.
Yeah, we could really work and make it. There's a lot of potential. This is classic research stuff that we should.
Yes, this is pure research. So it's proof of concept.
What is